Thank you very everybody for joining us today for the AIAA Los Angeles section mini conference. We have very exciting topic and very great speakers, and we have an exciting demo here. Before we get started, I want to point out some logistics here. For folks here, you are very encouraged to enjoy our coffee and donut. We even have a Valentine's Day heart-shaped donut in the kitchen. Sorry for the folks online. We really wish you are here with us. Have fun. It's beautiful Saturday, has sunshine. We'll miss you this time, but hopefully next time you can join us in person. But please join online, relax, have fun. So for folks here in person, the restroom is on your if sitting facing on the left-hand side on the back. This kitchen is on your right-hand side on the back. Other than that, I think everything we are pretty set. One thing is, if you are a member of AIAA, thank you very much. Please remember to renew. If you're not yet a member, please consider joining. Please ask me or any of our people. It's great benefit for you. We have free high school membership, free educator membership, and we're university student member as well. And by the way, if you are a member and you can enjoy benefit attending student conference, AIAA conference with discount, then we can recognize you for our section or recognized by other section. Also discount in national conferences. Sorry, this is AIAA event, so I have to go through this very important issue. So anyway, welcome for you to join us today. Without further ado, let's welcome Mr. Guanghan Ke. He's the president of the Grant System. This company, great company. I think he was. You already saw his bio online and his website. He has great service and products. He's very experienced, very knowledgeable, and also promoting education as well. So hopefully you enjoy his presentation. He'll tell you more about himself and his company. But I can tell you he is a great speaker and very willing to engage with the community. So let's welcome Mr. Guanghan Ke. Thank you so much.
Thank you, Ken. And good morning, everyone. And it was an honor to be invited to share our experience. And we started last year, we started working on the space sustainability. And gradually, we have put together a few solutions across the ecosystem. And today we thought that we would put together a few speakers to look at the topic of space sustainability, because there are a lot more spacecraft and vehicles in orbit now. And there are some concerns from the industry, and we hope that as engineers, we will come up with different solutions to help solve the issues. So today we have put together the session on the space sustainability, and the topic of my talk is space sustainability solutions. And so we put together these speakers. I will talk about space sustainability solutions and from Grant Systems. And the next talk will be Eric Long from Robotic System talking about the orbit track device. And I also invited Isabel from Space Debris Tau Distributed, and she's going to talk about capacity building for sustainable space economy. And hopefully we might or might not have the short sharing from the younger generation perspective on space sustainability. So we put together these few speakers to discuss the topic of space sustainability. And because we want to think about how to bring space sustainability solutions, I will first address from the topic of how to bring space sustainability solutions from a system integration role, and then how to integrate enough space sustainability solutions in product offerings. And then we will talk about how to create new innovative space that sustainability technology, and from not only one company but a series of companies, and then to do system integration from the very beginning of the product design and development cycle in order to have a larger impact on the space sustainability. And then how to foster new innovations in space sustainability in communities. And then Isabel will talk about how to bring in ecosystem to work with on this problem. And she's also going to talk about capacity building, and I will share the scale up issues. And then the next speaker will talk about the next generation perspective. So a little bit about my company, why I'm involved in this, and because we are Grand System is involved in new space, semiconductor and medical device. We come in from the perspective of system integration and also a think tank. We have done this for 16 years. And as a system integration partner of the industry, we think about issues. Ken? And we think about issues for space, for from the system integration point of view, and then and then from system integration point of view, first we benchmark different systems. And in my past work, I was a system architect in the semiconductor equipment industry, and happens to be luckily enough to be involved in the development of a very successful system. And at that time, we started from a system that was on the brink of being a failure on the market. And then we have to redesign the whole thing, the whole product, in order for this system to be successful on the market. And after we put in effort, 3 to 5 years of effort in product development, we changed the whole product appearance, product functionality, reliability, and all the system parameters to be suitable for its purpose. And it's suitable for the maintenance, suitable for deployment on the market. And then finally it will become successful. And it became a $3.5 billion revenue product in the 10 years of deployment on the field. So then we also benchmark what is currently successful in space sustainability in action. And that's currently SpaceX is the Falcon 9 is a very successful benchmark from the launcher point of view. Then when we look at system-wise, what else besides SpaceX, whether anybody else can duplicate what SpaceX is able to do, then we can work on the successful space sustainability solutions and to be implemented by other players, not only SpaceX, but a series of other secondary, third, tertiary system integration partners that are able to also implement space sustainability solutions. Yeah, moving to the second screen. Yeah, no problem. And so and that was an exercise in my mind, how to generate uh, solutions and also to bring in successful commercial implementation and operations in order to have a survivable business and also successful systems on the market. Then we so so for the thesis for successful space sustainability, we have to look at the challenges of the sustainable life in space and other celestial bodies and find out the financial and logistical challenges to implement space sustainability and the technology development and the cost of developing the hardware and missions and the key components for the sustainable space exploration and all the different issues and solutions that we need to go through in order to achieve successful uh, um, uh, missions and also to think about why we need to do space sustainability for to improve the business operations and also outcome. If I can excuse us for the okay. So a few key challenges for space sustainability is one is resource management, and another one is energy efficiency, waste recycling, ecosystem collaboration, and also in situ resource utilization. So when we look at different items and each one of them will have a series of technology development and each one will have key challenges and key opportunities. So when we look from the system point of view, and we just saw that on the launcher side, SpaceX has been very successful. On the satellite side, you will see that we are starting to have solutions like what we have here, that we and Eric and a few stakeholders are devoting our efforts to make it a little bit more successful. And on the hardware, material, missions, and life support portion, we will become gradually moving from that end to this end and working on solutions. And all through this level, from looking from the system level, there's also the outcomes that we don't want to have is the debris. And the debris portion we will also need to address separately or collaboratively when we look at the system numbers. First, from the launcher side, it was very successful from SpaceX. On the larger constellation Starlink side, for example, tens of thousands in the system number. And on the smaller satellite, on the CubeSat side, we have from hundreds to 1 to 2,000 of system numbers in terms of opportunities for bringing in the solutions for space sustainability. And when we look at the system number, and that gives you the size of the potential market and also the system numbers that we need to design the systems in order to solve these kind of solutions. However, on the debris side, it can be a little higher than this number, and that's another opportunity for bringing in the solutions. And the thing about space debris is um, we can look at the space debris from past space debris to this point, and from this point onward, how to design the solutions in each situation. And we'll discuss some of the situation today by different speakers. And from ground system side, we work on space access, and space sustainability solutions from the integration point of view, and looking at space debris and the orbit opportunities, space recycling and resources, and especially on the space manufacturing and the mass production methodologies. And in the past, we are known as the colorful CubeSat companies. You can see some of the products here. And we have produced for more than 100 CubeSat subsystems, and we have flown full CubeSats mission to ISS, and develop CubeSat buses and take hardware and missions. And the experience has been developed from the single mission and to multiple missions and to supporting other people's missions in 47 different missions. So we started from one mission and became hundreds of hardwares, and we have produced quite a few hardwares, and truly in mass production mode, so that hardware, instead of making one spacecraft, we try to have methodologies to make annual production of potentially 500 satellite capacity in our factory. But of course, currently there's no demand for 500. So we right now focus on the production of the 100 CubeSats. So we look at the space sustainability after we are working on mass production. So as a mass production house, we have the social responsibility of wanting to have whatever we make, we want to bring it back to Earth. Because as I mentioned, I had the privilege of and the fortunate opportunities of developing very successful $3.5 billion system in the past. And it's actually, it was an experience to deploy $3.5 billion of world's resources globally. And it's, in some sense, it's a painful experience that we used up a lot of the resources on Earth. So coming back to work on CubeSat the second time for mass deployment of systems, we want to be responsible and from our past learnings. So you see, we have all the form factors from 1U to 16U, sometimes even larger to into the small sat form factors. And how do we ensure that we can help all of our customers to bring the satellite down? That's a concern that we have. And we weren't quite sure until we started to work with different solution providers and also ourselves to make sure that we have solutions coming forward. And we have the hardware to work on the different solutions, and some of the work has been recognized by NASA and the industry to be included in the state-of-the-art report. And our past experience has been in semiconductor industry to be included in U.S. Malcolm Baldrige National Quality Award and also Taiwan National Quality Awards in different companies. So this experience, we started putting together and was from the system point of view, including different technologies, and we call this re-entry ready CubeSat with the drag, the orbit drag device that you can see here, and the next speaker is going to talk about the specific technology involved with bringing in the satellite from orbit after the life of the satellite, and to satisfy the FCC end of life 5-year rule. And Eric, the next speaker, Eric, is going to talk about advancing small spacecraft deorbiting and on the D3, and so from system-wide and also product development process, we look at we have users and the suppliers needing to come up with the needs and the business concepts, and we need to develop into conceptual design processes and also test our considerations and implementation into operation. For the development cycle, we need to go through all different activities, and of course, the best idea is to work early in the process in order to avoid the cost of correction. When we catch most of the issues in the beginning, it will save a lot of the cost in the large scale implementation. And if we don't do that, the cost of errors is going to be skyrocketing later on down the road in terms of commercialization when we increase the size of the system numbers. And for example, in my past experience, when the system number becomes 10,000, 100,000, if one error you have, it's going to propagate in the field. And when it's in the field, you are trying to catch the problem and try to bring it back to make solutions. And that's going to cost a lot, and especially in the sense of satellite and spacecraft, we are not able to do that. So how do we deal with this kind of problem? We need to think of it in the beginning and in the design phase and the mission and the definition. So from the mission's point of view and also life support that we were discussing, and we started the industry started addressing from the launcher side, and I mentioned that we addressed from the satellite side, and then we will start to think about from the mission point of view and also life support point of view. And of our experience in the mission has been in the man-Mars missions and also lunar rover type of mission concept design phase, and we participated in a few mission bids, and even though some were not successful, we went through the process, and we were contracted to do design manufacturing of a lunar lander payload missions. And from the space sustainability solutions, we were also thinking about possible application using our existing satellite solution, and possibly think about it from the airline industry and having, sorry, having the beacons and to tell the directions, and possibly instead of having using the light, and which the astronomers will go against, then we will think about non-light pollution option, and to have something similar using the similar technology to implement some kind of quasi beacon receiving type of solutions that are already existing from our past missions. And we were also involved in microgravity research, whether there is any, we can look at potential opportunities for space sustainability, especially with regards to life support and also other systems, space food and other biotech, pharma material commercialization point of view. There are a lot of potential solutions and opportunities that we can create as potential space sustainability markets. Of course, and then we also work on, we design a tiny space factory, and to hopefully go on the ISS to do material characterization, repeatable samples sets, and this kind of research, and to possibly look at helping support on the sustainability solutions in terms of nutrition and material characterization and manufacturing in space. So this is the kind of environment that we are looking at in the space station, and also potentially from the International Space Station going into the CLD type of environment. And how do we do the space sustainability solutions from research point of view into the production point of view? Is a different shift of mindset from research to production. And then we will need to do a lot of shifting and rethinking of how the process can be done. And from ones to single digits of usage case application and implementation into hundreds, thousands, tens of thousands of repeatable usage and manufacturing type of solution and implementation. And the system scale needs to be designed in the beginning, and the process management and etc. that needs to be implemented. And of course, and then we think about the missions such as lunar lander payload, and we had the opportunity to look at this kind of mission design. And of course, this kind of mission design currently has been onesie, twosies. We don't have the system number for large implementation. However, if we are thinking about Artemis type of missions, and some of the mission automation and larger scale implementations of, such as lunar base building and also the space mining, where you can be thinking about thousands of automatic vehicles, such as this kind of vehicles, concept vehicles that can actually be implemented on the lunar surface. Then when the system number is large, you can have reliable systems, and you can start thinking about space, the sustainable issues, because it's going to save you a lot of money, because each mission is going to cost a lot. So it's going to be a very important issue when you implement, and especially when you start counting the space economy, and also looking at the cost counting and accountability And when you are even running a business, then you need to look at profitability, and every single number is going to be very critical. And then, of course, when you have the system number going up, then we need to look at the scale up issues. And the next speaker is going to talk about the D3. And so our role in the ecosystem is for scale up. So when he think about the technology, I think about at the technology times 1,000. And so we need to look at the scale up, hardware, and material. And not only at the specific technology, but as just as a spacecraft itself. And right now, we have different opportunities to uh, have to build a spacecraft. But spacecraft we are used to doing the standard aerospace material, aluminum. But when the system becomes larger, when the amount of aluminum in the atmosphere burning up is larger, we need to think about as a manufacturer, when we are the socially responsible manufacturer, when our system is in the hundreds of satellites, we are thinking we need to bring down the lowering the amount of aluminum use and burn up in the atmosphere. So we started thinking about potentially using carbon fiber, and first being lighter material. Second, when it burns up more easily, and so we at least need to have an option as customer wants to choose. And of course, in order to do that and in order to scale up, we have 60 metric tons of equipment doing the manufacturing in order to do hundreds of satellites. And for scale up, we can do all different sizes. And so these are all the existing infrastructure available to the industry. And of course, material is not an issue from the manufacturing point of view. We have existing capabilities to do metallic, ceramics, and carbon fiber, and many different ways to work on manufacturing technology. Even we are able to work with regulars, even though lunar regulars is a very hard material to work with. But it's similar to quartz and ceramics. So we are able to work on that. And when trying to look at the construction using the regulars and using different methodologies, and hopefully they are sustainable in the process. So right now we are looking at the solutions. And of course, from spaceflight, from satellites, from launchers to commercial space, and to think about space economy. And we need to think about how to collaborate with different partners, and how to implement. And this way we can have a different economy. And of course, the third speaker will talk about the sustainable space economy and the capacity building for that from the ecosystem point of view. So I address it from the system integration point of view, from system numbers, and from implementation and scale up of the technology. The next speaker, Eric, is going to talk about specific solutions from the solution provider points of view. And the next speaker is going to talk about the sustainable space economy as of overall as an ecosystem. So the work continues, and we invite all the solution provider to come and work with us. So hopefully we can bring our system-wide space sustainable and make it into a space economy. Thank you.
Answer some questions. The great presentation. So any question from people here online? The next speaker, Eric, Mr. Long, start from 11:30. So we have a few minutes. Oh, by the way, so the program as you see online, the next presentation is 11:30, and Isabel is going to present online 12:30 Pacific time. Then we'll have a panel discussion so the speakers can answer more questions and have more conversation. And Mr. Ke can also show more about this demo he brought us today. Very exciting. But you're welcome to ask some questions specific for this first presentation. So any people here and folks online, for people online, you can just unmute yourself and speak out. Oh, you have a question here. Go ahead. People can hear you.
Okay, I don't need to speak microphone, right?
If you want, you probably need to come here.
Okay, I could just ask. So I think the
Can you state your name?
Dan Kalu from JPL.
Thank you.
Okay. So my question really is, I heard that you started in production, and I work for JPL. We're never in production. Our production number is number 1. That's all we do. So so my question really is, for the military, they are thinking about the digital twin because, for example, the fighter, right? And so they think about digital twin here. So now you're in the production here. So have you thought about digital twin? So that will allow you to have a lower cost to sustain the system here as well. So I just wonder, would you comment about that one?
Yeah. Thank you, Dan Kai. This is a very important topic in terms of manufacturing and scale-up implementation. Traditionally, there is some kind of digital twin, and whether it's implemented in the smaller scale or implemented in the medium implementation, or when the resources are available, you have large-scale implementation in digital twin. And it really depends on the system number, and it also depends on available resources, and from the R&D, design, engineering to manufacturing and implementation and operation. And when there are enough resources, when the value is high enough, that it will be implemented for sure in different scales. And when resources are available, or when resources are not available, some portion of it will be implemented. When more resources are available, the full set needs to be implemented.
Okay, thank you.
Robert Phipps, you had a slide on printing the lunar regolith simulate. Can you elaborate a little bit more on that?
Yes.
Yeah.
So
the next slide was you were printing from it. So I was wondering what you're printing and how you're doing that.
So first, we make the effort to produce the lunar regolith. But before we produce the lunar regolith, we went around the hunt for the rocks that are suitable to make the lunar regolith. It itself is a learning experience. And because different rocks come from different mountain, and the different mountain will have different constituents. And the manufacturing process will cause different particular size and the different manufacturing method. And from that experience, and then we need to work on the Of course, there are a few years in between. And then we need to first find the tool set suitable for the printing. Second is we need to find the methodology for printing. The third one is the previous material preparation is actually not straightforward. And whether I do it in Taiwan or I do it in California, I will have different result.
Why is that?
Oh, yeah, what's that?
Humidity, particle size, different the methodology.
Even you manufacture inside the controlled environment, you are not going to go to outside.
And we think we are in the control environment, but it might not be the control environment. It might not be the same.
Gotcha.
And so we think it's control, but actually it's not control enough. And so the printing is, the result of the printing is different. So that means we need to keep working on the details. And after working enough of the details, we are finally able to print. Before, we were not getting good enough solution, and then until we are able to get the solutions, and we solve all the problem before.
I want to follow up because this is a good question. Right? Well, I work on the Mars rover right now. Every time we have a different the rock we try to drill the things, and we have no idea the property of the rock, right, until we get there.
Yes.
So this could be an interesting, right? Before you do that drill, and we can just 3D print that in the lab. We try it out first. That's only take a day or so to try it out.
Oh, yeah.
That's right. Instead of we drilled, and we said, "Oh my God!" Like a couple of days ago, we drilled and we did not get anything. The tube is empty. Right? Because it's just a particular property of rock. We did not know that.
Right. Yeah.
Right. And that's actually very interesting because
How come I did that?
because we designed this concept rover 5 years ago, 6 years ago, and we designed it so that there's a nose. Then we put the spectrometer at the top, at the tip, to first look at the material. That's our first thought is we want to know what the material is, so we put a spectrometer there. So we hope that is one of the concepts that may help.
Well, the problem is you think you know the property of the rock. When you try to drill that, it's very different. So I was thinking about it. You could take the information you have, then you 3D print out in your lab. That only take a half day, right? And then you try it out and go back and drill.
Yes.
Then it goes back to your digital twin. You get the first more information about what you do.
And the limitation there is the rocks. He would have to have the rocks available. The lunar regolith, honestly, that's just from where we sampled. It may not be where we end up.
True.
And he's trying his best to, and he says that apparently in California, it's a little different than in Taiwan.
Yes.
Just because of the way the rocks, how they got different sources and then they're not stored the same.
And the weather too.
Yeah. It surprises me since it would be, you try to make it a controlled environment, but I guess your materials are not in a controlled environment. They're outside.
You think it's controlled environment, but actually it's not.
Yeah.
Until you find out.
Until you try it, yeah.
That's from our experience. We thought we have a controlled environment, but we send the sample through the postal office, and that's not a controlled environment.
Yeah.
So is the regolith being used as for 3D printing, or is it being used like a ceramics kind of thing?
Oh, I'm sorry, can you state your name?
Sorry, I'm Patrick. I have a question: is the regolith being used for 3D printing, or is it being used like construction as like a brick or like ceramics kind of stuff?
Yes, we were thinking of using the regulars. Um, Initially thinking about for 3D printing, but later on we did the literature search and also think about manufacturing technologies, and we end up using. I mean, it's 3D printing using SLM methodology, and then we tested with the laser to see how effective the bonding is. First, without using any binders. Then we are going to do the with the binders. Am I answering
And
your
what?
question?
Yeah, and what is the advantage of that over like materials that we have on Earth?
But when we are on the moon, we don't have the material on the Earth. So we don't have to
Sorry,
bring. So we don't have to
could you
bring the
repeat that?
material from Earth to the moon.
So this would be in Luna production.
Yes, to simulate the production on the moon. But we need to first find out how we deal with the material here, trying to guesstimate what the situation is on the moon. I use the word guesstimate.
This is just simulator.
Yes,
Yeah,
yes,
this is-
yes. It's a the manufacturing methodology demonstration.
But how do you validate your symbols? How do you know it's right?
First, we need to prove that we can do it. So we are in the stage of proving that we can do it. Then we think about how to validate. We are in the first stage because the material is not easy to work with. And the next phase we will think about how to validate. Patrick, did I answer your question?
Yes, thank you.
Thank you.
Any more questions from online? You can keep thinking about the question to ask. As I just mentioned, we have a panel after the next two presentations. But any people here? Any question here?
It's Robert Phipps. Can you elaborate more about the regolith? You talked about it. What makes it up? Is quartz, silicon? I know it's sharp because it was causing issues with the astronaut suits, but can you elaborate a little bit more about how hard it is to work with?
Yes, regolith is from the Apollo sample. Most of the regolith has about 40% quartz and a little bit of other materials, some metallic, some ceramic, and other constituents. And quartz and the regulars has, because of those constituents, some are ceramic behavior, some are metallic, and some are mixture. And the real regulars will have sharp, pointy features, but the ones that we make might not have as sharp, pointy features. And for the ground test, our current production equipment actually prefer round particles instead of pointy particles. So material preparation itself is very ground-based thinking instead of moon-based thinking. So equipment tool set itself, we cannot use the ground-based production equipment to do this kind of research because it doesn't fit. So we have to specially redesign the equipment for desktop portion to do mass manufacturing of lunar regulus bricks. So the design thinking is different between the Earth and the Moon. So because the tool set will be different, we need to think about the design, manufacturing, and the design the tool set we use to make the manufacturing happen in order for that to be sustainable operation on the Moon.
So this is just one type of rock, right, on the moon.
Possibly one type of rocks. We don't have enough type of rocks to test. But from the Apollo samples, Apollo 11, 14, and 17, 18, different rock constituents are not very that heavily compared to the ground material that we have. So for the 3D printing manufacturing of the ceramics, we have a larger variation of the material, but our material shape is not the same as the lunar regulus. The variation of the material is larger on Earth than on the Moon.
This is John Briza. I just want to comment on some of the space sustainability issues that you brought up, which just heads up heralding you for as a space systems development company that makes hardware. Talking in such terms is really, really wonderful. I mean, not enough people are talking space sustainability for the long term. And I really, really appreciate that you're bringing that out in such a systems engineering way. The long-term goals are where it's at. You stated it so well. So my question really is in terms of that resource orbital economy that we would hopefully be getting into relating to space debris, and if we are able to eliminate or phase out burning up space debris in the atmosphere and then phase in a resource orbital economy, what would that look like if we are able to get to a safe resource orbit and then recycle some of that material? Have you looked at that, or are others looking at that in terms of how to repurpose some of those materials, for instance, as a space scrapyard, a safe space scrapyard? Thank you, and I'll leave it at that.
Thank you, John. Right?
Correct.
Yes. We are currently looking at the issues from, as I mentioned, from this point onward on future spacecrafts. Currently, there are other players in the industry, for example, Astrobotic, and no, there's another one, Astroscale. Astroscale is looking for current debris. So, and there are other companies that are working on robotic systems. So there are another company working on detection. So there are several companies in the ecosystem addressing different point of view. And most of them are looking at existing debris on orbit. And we are looking at future not causing any debris. And of course, current debris on orbit is a more difficult challenge than what we are looking at for future reducing future debris. And of course, currently we still lack the commercial vehicles such as insurance companies to jump in to look at current debris removal. And but I think to solve the issue from this point onward, we can bring in more opportunities, because we can actually potentially look for insurance premium reduction, and also other financial vehicles that are potentially benefiting for future implementation. I don't know whether I answered the question.
No, yes, very much so. I think, yeah, bringing in the insurance and commercial end of it I see as a way that we will we could monetize space debris. And it already is monetized at this point. It has a negative value to it. So, there are some space debris. Second stages are quite large and can be reutilized in the future. So if there is some way to monetize space debris, I think it would enhance that commercial and financial end of it. By burning it up in the atmosphere, you're just burning up money, I think. There's value to the space debris. Thank you. But that's what you answered the question well. Thank you.
I think we are still learning as how to make this into an economy.
Yes.
I think that it's time for the next speaker, but I want to say a few words because you mentioned several things. Actually, John was there last week, right? John, you were in the USC student USC presentation last week, right? We have
Correct.
a
Yeah, it
speaker
was
last
very well
week.
done, and that really talked a lot about how it's uplifting now. The space sustainability issues are being brought out, and it's wonderful you guys are all doing it. Thank you very much.
Yeah, we really feel appreciated because this space sustainability is a very important topic. So we have back-to-back presentation last week. That USC PhD candidate, he just actually got the European Space Agency Awards on space sustainability. So it's a study sponsor, NASA, kind of awarded by ESA. So today we're also very happy, honored to have the three distinguished speakers to talk about it because this is a very key subject for AIAA right now. The second issue I want to mention is that because actually Guanghan talked about not just the LEO or the microgravity, he also start to talk about Moon and Mars. In case folks online might be more used to the space debris issues, you should pay attention to the December announcement by NASA. They have the LEO microgravity strategy. If you look at the picture itself, you have the ISS in the middle, but then you have Mars and Moon in the background. And in the SciTech last month, in AWS SciTech last month, the associate administrator, Mr. There's Free, and he actually, and also the deputy director, I think they probably no longer in the office because we have a new administration, but they talk about this new strategy. The purpose is to send human in a long duration, human spaceflight safely to the Moon, Mars, cislunar orbit, and back for long duration mission, longer than 6 or 9 months. But NASA really want people to benefit from the past 20 plus years of the ISS LEO microgravity research and the knowledge acquired from the past many years for biological, physical material. That's very important. And I happen to be the AIAA used to be called Microgravity and Space Process Technical Committee. I'm the current chair. Now we changed the name to Gravity Dependent Science Technology, but it's related to microgravity. And the space processing that Guanghan mentioned is very important. And we have been actually working with Vast Space, Axiom Space, and many players that Guanghan talk about astroscale astrobotics. One thing I also noticed recent, talking about material, silicon, actually there was a news recently. I think one of the executive from Axiom Space, I think his name is a Japanese American. He flew to Taiwan, talked to TSMC. They want to invite Taiwan Semiconductor Company to participate Axiom Space semiconductor manufacturing experiment in space. So there something might come up with Axiom Space pretty soon. Actually, I thought about it, but they were very fast, faster than us. So I think there are a lot of exciting things to consider. So this is answering a very important, exciting topic, not just for the space debris. And the people are just asking about using the space debris as material and talk about the regoliths. These are very important for in situ manufacturing as well. So there's a bigger picture. And this picture actually pretty much in line with the NASA picture in the recent LEO microgravity strategy. So. Do we have Eric?
see. I think.
And
Oh, okay.
this I should we do it first. So basically,
Oh. That's it. Sure, not a problem. Oh, there we go.
thank you. This is green. Green, up, down,
Okay.
great. I'll make it lock it.
All right. Well, thank you. I appreciate the being invited to. I appreciate. Did I turn this off? There we go. I just want to say I appreciate being invited to speak here, and thank you, Kwang Han. We were actually at the symposium in Silicon Valley for a week, and we were working together and just arrived back last night, actually. So we've discussed space debris quite a bit and some of the technologies that Kwang Han was talking about. Also, I'm pleased to see one of my colleagues and co-inventors of the D3 is here, Dr. Dave Guglielmo, and nice to see you. So what I'd like to talk about today is not so much the space debris end of the device that we developed for using passive deorbiting, but more along the lines of actual maneuvering in space using alternatives to propellant thrusters. So I'll start with a brief background on myself and the company. I'm the CEO and co-founder of a company called Orbotic Systems, and we founded the company in 2020, middle of 2020 in June. Our focus was on space debris remediation and sustainability. So we have two primary focuses right now. One is on passive maneuvering and deorbiting. So not so much space debris remediation, but more along the lines of mitigation, and also on space weather detection. So we're working on a system with NOAA at present time to increase the capabilities of their space weather prediction center. And that's something I wouldn't mind getting into once we've developed some more test data. But to begin with here, what I'd like to discuss is the D3, the deorbit drag device, and how we're implementing that in a test in May with Axiom Space. So our focus, again, is not necessarily to determine whether or not the deorbit drag device will work and deorbit a spacecraft. We basically know that. We had our first test flight in, it was launched in July of 2022 aboard a SpaceX CRS-25 mission, which there's data online if you're interested in that. And it was released from the ISS in September of the same year, and we were able to have a successful launch there. So the satellite has deorbited, but that was strictly just a test to determine whether or not we can deorbit a spacecraft using drag in low Earth orbit, and not to do any maneuvering tests or to try and control the rate of descent, or whether that includes speeding it up or slowing it down. So for those of you that are not familiar with using drag as a maneuvering mechanism, I'll just start off with a sort of a high level explanation. Maneuvering without thrusters, we can use drag to do that up to about 700 kilometers because there's enough molecular density in low Earth orbit to create a drag effect similar to a sail, where you're able to slow the spacecraft down. And drag's been around for a long time, of course, long before any of us were here, and long after we're gone, I'm sure. But controlling it in this environment is relatively new. However, there have been a number of different companies and government agencies that have been implementing tests on this. So one of which is, of course, comes to mind first is NASA, and who we've been working with in this area. Also, there's been a few private companies, and I'll show you some of their designs here. You can see that to the upper left, there's a company called Vestigo, which is local to the LA area. And they typically use, it's more of a chute than it is any type of a boom or maneuvering system. So you can imagine a giant parachute in space that's slowing the spacecraft down so it will deorbit. To the right of that, credit is actually Millennium Space Systems, but the image is for a satellite that used solar panels, excuse me, to control the descent of the spacecraft and slow it down. It was, I believe, Planet Labs, now Planet, was the first commercial spacecraft company to go ahead and use drag as a controlling mechanism for their spacecraft. And then below that, we have a credit to NASA for one of their products. And also MMA Space has essentially a giant parachute that they've developed that unfolds so you can deorbit a spacecraft. However, my favorite deorbit device is the deorbit drag device. And so the picture to the left is a picture of me from 2021 holding the I believe it was the actual second prototype ever made. And as Dave here is familiar with that, we were able to shrink that down considerably in 2024 for an Axiom spacecraft. The mission is called Igor, and that's the one going up in May of this year, assuming we don't have a slip. But why focus on any of this? Why focus on using drag? I mean, we have thrusters. Thrusters have high delta V. We know that they work. What's the benefit? So why passive deorbiting? There's quite a few benefits, actually. It's just a matter of how you approach it. So aside from a convenient and easy system for deorbiting a spacecraft after the mission life cycle is complete, you can also use it for doing maneuvering and mission science at different altitudes. A few of the other items that you see here that aren't commonly talked about, excuse me. Oops. Looks like I went too far here. Let's see. So some of the less commonly talked about items are staggering spacecraft constellations. And constellations are becoming quite a big issue in this day and age. And so being able to control the distance between them is important. Also improving radar visibility. So now you can do that if you have a smaller satellite just by using what, in our case, booms that will create larger area so that you can pick up the satellite easier. Another, what I consider a valuable asset is that you can you're able to perform multiple missions with one satellite that might not normally have thrusters on it. So if you imagine that you're doing mission science at, say, 650 kilometers, and then you want to go down to 400 and then do mission science again with the same spacecraft, and then deorbit it after that mission is complete. You can do that with a simple passive deorbiting system where it's with using thrusters and propellant that would increase the cost and the swap quite a bit. So those are just a few. Also, another one that we get a lot of questions about is the ADCS, Attitude Determination Control System. So part of the reason why we're doing these tests with Axiom is to see if we can get an effect that mimics an ADCS. So if we can replace that by using drag, or at least use it in a multitude of cases so we don't need an ADCS. Now in many missions, you can replace the thruster system and the ADCS with the drag-based system. So that's a huge cost savings and also size, weight, power savings. So ultimately, especially with smaller spacecraft and commercial spacecraft, cost is an issue. So that's another big benefit of the passive deorbiting. Again, we went through this. So this is a diagram here of essentially what our device looks like on a CubeSat. So you can see there's a 3U CubeSat maybe 4U CubeSat there. At the base of the satellite is the deorbit drag device, and it has 4 booms which retract. And the booms are, when they're fully retracted, it's non-obtrusive, so they don't extend past the perimeter of the spacecraft. So that helps in terms of deployment. If you can imagine, if you're using something like a NanoRacks deployer, where it has to fit precisely in that environment, that's beneficial. And then when it's full, when the booms are fully extended, in our case, they extend to 3.7 meters, so a little bit over 12 feet. So without reiterating what we talked about earlier in terms of the benefits, the solution benefits to our system specifically involve the small size. As you can see on the second generation, it's about 1/3 of a U on the Z-axis, and then 1 U on the base. Also, again, there's no explosion risk because you don't have any kind of volatile propellant. And in terms of the cost, it's much less than thrusters. I'm sure if you've dealt with thruster costs and propellant thrust and also the testing involved, you know that it can be a complex system in many cases. We're able to, based on the modeling we've done, I mean, we've had a limited number of on-orbit tests, but based on all of the modeling that's been performed, we estimate 700 kilometers is our ceiling in terms of being able to utilize the device. And again, we'd like to be able to verify and validate that we can replace an ADCS system. Also, the turnaround time. We're looking at about 120 days in terms of turnaround from the first order to the time that we can make delivery. So that's pretty quick in terms of the space industry. And it doesn't require any type of ITAR. So if we're dealing with European customers, we've had some questions come out of Europe and also from Asia. Unless we're implementing an electronic control board, the mechanical device itself does not fall under ITAR. And last, it does allow for late stage integration because it's fitting into the base of the satellite system. I think I lost my control system. Okay, so some of you may know that about the physics overview on this. Some of you may not. So this is very high level. Basically, what's happening here is that we're dealing with the ballistic coefficient, the actual density of the atmosphere, because there still is an element of density in space up to, again, about 700 kilometers or so, maybe a little higher. You also have the effects of solar activity, and then just the gravitational effects of the Earth and Moon in general. The ballistic coefficient is what's going to determine the resistance to the atmospheric drag. So just as a general rule, the higher the ballistic coefficient, the longer the lifetime in orbit. And then the D3 itself, what it's doing is by extending 4 booms and controlling the distance of those booms, you're modulating drag, and you're essentially what you're doing is you're altering that ballistic coefficient. And then the atmospheric density, like I mentioned earlier. So if at different altitudes, you're going to have a different level of atmospheric density. The lower you are, the more density you have. So that's going to affect how fast the spacecraft deorbits or how quickly you can make a maneuver. So mass properties of what our D3 is pretty low on this generation 2. It's under 1 kilogram. You're looking at 934 grams is what the Axiom model was when we delivered it. And here's a calculator of tests we ran, some modeling we've done for different types of spacecraft. And you can go ahead and see here, the altitude is on the far left. So we're looking at essentially a range of where a lot of the smaller satellites are operating today, and at least in the LEO environment. And you can see that looking at the 6U, 12U, SciSat size, and the various different kilogram mass, that we're able to deorbit the satellite under 5 years with a D3 attached. And then many of these on it, you can see without a D3 are not able to meet that 5-year orbital life demise limit. So part of the reason that we built the D3 from a remediation or a mitigation standpoint was to meet the FCC 5-year rule. When we started working with it, we didn't know for sure if that would be passed, but there had been quite a bit of talk about either NASA or one of the other commercial agencies like FCC instituting a limit on how long a spacecraft can stay in orbit once the mission life cycle is complete. And as it turned out, it was the FCC that instituted it, the 5-year rule. It was not NASA. But we did run the D3 by FCC. We had an opportunity to demonstrate it and then also discuss it mostly with their legal staff. But they did have some scientific advisors as well. They will typically not endorse anything, any type of technology, but they did say that they like the design and they hope to see it on more applications for launch. So we thought that was a really positive meeting and experience with them. So as far as the Axient mission is concerned, we have some objectives that we'd like to accomplish with that. We're going to be changing the lengths of the booms, and I'll get into a little bit more of that in a few minutes. But the primary items that we're focused on are rate of change. We want to see if we can verify and validate that what the rate of change is as we control the booms, as we retract them and extend them. So we basically already know that it's going to work when they're fully extended and take the spacecraft down and just in the demise once it enters the altitude, disintegrate it. But we want to look at it from a control standpoint. So this will also allow us to do some drag analysis. We want to see what the actual results are compared to what it is that we're projecting and propagating. And then also just make sure that the functionality in and on orbit will continue to work as we're doing these tests. Oh, by the way, in case you're wondering, it was originally scheduled for 2024, but it was pushed back to May. So the mission patch says 2024. So the integration process here, this was already integrated onto their satellite. There's an image over there on the lower left-hand corner, and that was a fit check. So we went ahead and delivered the D3 to New Mexico at Kirtland Air Force Base, where they have where Axient has their Igor lab. The D3 device was integrated successfully, and there was a functional test performed. So that essentially involved retracting and extending the booms multiple times through various cycles. We also did a temperature and vacuum test on it, a vibration test, and basically all of the standard tests that would be performed with the NASA GEV specs. Power consumption is very low. You're looking at about 1/4 of an amp per motor and fluctuation from 5 to 12 volts, depending on how much you want to torque the motor. And also works out to about 1 watt per boom total power consumption. So the swap is very low. The first test that we want to perform is an extension of the booms to the maximum amount. So again, it says 3 meters there, but its total length is 3.7 meters. And what we'll do is on pre-deployment, we want to stabilize the satellite and then make sure the battery's fully charged. We'll deploy the booms fully, and then that'll take about 120 seconds mission elapsed time. Once we do that, the satellite will send its current state, any changes that we've measured, and then we'll go ahead and calculate a new orbital lifetime based on our ground modeling. But then we want to compare that to what's actually happening in terms of how quickly the spacecraft is now lowering its orbit or its altitude. So the next test that we'll do once we've received all the data that we want from that first one is we're going to go ahead and retract the booms to about a third of their total length. And now this is moving into not so much again of an idea, determining what the maximum demise or the maximum deorbiting time can be raised to, but it's really to determine how the changes in the booms are going to affect the maneuvering or how it will accelerate or decelerate the spacecraft in terms of lowering the orbit. So essentially, it's the same sort of a process that I mentioned for the first test, but again, we're retracting it a third of the way, and without going into repeating the same process for each of these, you'll see test 2 is essentially the same. We're going to bring it out to 2 meters on test 2, and then for the final part of the testing, we're going to fully extend it again, and then we'll have the complete demise of the spacecraft. The reason why we're going in this order is in case there's some sort of a failure, we want to have the booms fully extended on the first test, bring them in to the smallest level on the next one, and then continue to move them out. So that way we're not creating more space debris and breaking the 5-year rule. So this is a summary of basically what I just discussed here with the orbit test procedure. We'll go on to the D3, the pre-deployment, which is taking the 2 line elements, the TLE values, doing this stabilizing the orientation and making sure the battery is fully charged, doing the D3 extend retract on the booms, whether or not, depending on which test it is, that'll determine how far we go out. Then after that stage is complete, we'll consider the test procedure complete, and that's when we do our calculation for the next phase, the propagation of the orbit. And then the final phase will be actually doing the testing, collecting the data, sending it back. And then essentially it's just repeat and with each boom length. So this is a list of the success criteria as far as we've determined for what we're going to call a successful mission. And we're going to start with the compatibility level, then deployment itself. You can see some of the points there in terms of under deployment, track CubeSat with ground radar, radio contact with host satellite. Then the boom operation will be calculating the projections that we believe the orbit will take place and the altitudes that the spacecraft will be functioning on. Then also we'll be comparing that with the TLEs that are actually collected, and then also CubeSat GPS data. So the satellite will also have a GPS on it. The attitude control, that's really internal to robotic systems in terms of what we consider success. Axiom's essentially out of the loop on that, but we do have the option to run various tests or keep those booms extended for as long or as short as we feel is appropriate to gain the data that we're looking for. So the final demise is if everything goes successful, then the D3 will lower to an orbit where it'll start to re-enter the atmosphere and then burn up. So we'll have the satellite passivation and the satellite into mission, and then the atmosphere ballistic entry or re-entry rather. These are some of the numbers that were on the calculator that I showed you earlier. These are 3 that stood out to me and I thought would be good to just repeat in terms of what we had as what we're expecting to see with various satellite mass and size. So with the 6U, and I believe these numbers were based on a 20 kilogram satellite. We're looking at a cap of 622 kilometers to do the 5-year or under deorbit. 12U is 578, and then we had 160 we calculated out to 565. So, but that 565 kilometers, right? So a couple of use cases for the D3 also where we could perform multiple missions and obtain different types of data sets. There's obviously the smallest would be a 1U CubeSat. There's probably not really a huge drive for that. I mean, most of the satellites that we hear about are the interest is in increasing the size of the satellites, not really making them smaller. But 12U seems to be a number that keeps resurfacing, as well as some of the larger satellites in the area of maybe 16 or 20U, and up to about 180 kilograms, which is where our maximum mass is at for one device at this point, according to our modeling. Some of the other spacecraft that we are looking at in terms of just maybe larger size are here, like where it says small spacecraft, 400 pounds, 180 kilograms, ESPA class. One of the samples or examples that I can use for this is that we had a conversation with Astroscale about 2 years ago, and they were interested in a scaled up D3 for their ELSA-D mission. And what we did is we were able to model a larger D3 that was with our colleagues over at Embry-Riddle, and they came back with a number that was roughly, I want to say, about 700 kilometers is where we were able to essentially cap it using drag. Otherwise, the curve on the results doesn't make sense to do it after that, is what we determined with our design. So we communicated that over to Astroscale, and they were interested because it fit the range for what they were looking at doing. But because they wanted a little bit faster, less time, I should say, for their deorbiting, they decided that they were going to look at other options that were propellant based. But the concept was the reason why that they were interested in it is because you could attach the D3, the scaled up version, to their satellite, lower it without propellant to a lower altitude, then release the debris that they were able to capture, and then raise the satellite back up to a higher altitude using thrusters and propellant to capture another piece of debris. So that was the idea behind it. So the key messages coming from the presentation here and about the testing are that why use passive deorbiting or maneuvering? So you have the obvious space traffic management. You could do a collision avoidance maneuver, as long as you have some sort of advance notice. The staggered constellations is another big one, and it's getting larger. And then, of course, improve visibility with ground radar or other types of remote sensing when the booms are extended out. Summary of benefits similar to what we just looked at. You're able to modulate, drag, and control the orientation of the spacecraft, potentially not just lowering it or maneuvering it, but maybe changing the orbital trajectory. That's a little bit trickier, but that's something that we're also investigating and working on. In terms of targeting your deorbiting or your location on orbit, we do have a targeting algorithm that's yet to be tested, but we are going to be doing that on another mission early next year. So the idea being here is that there's feedback from an algorithm to the booms. They're individually controlled instead of operating simultaneously. And then by individual control, you're actually able to do the maneuvering for the spacecraft. And again, scalable system. I didn't really talk about that, although it comes up quite a bit. So what if you have a larger spacecraft, or maybe you're just on the cusp, or you want to go to a higher altitude and you're not able to deorbit in time based on the numbers we're getting? There's really no reason why you couldn't use more than one. So let's see, as an example, take maybe maybe a 16U, so it's 4x4. You could go ahead and have 2D3s kitty corner. You wouldn't be able to use all 4 booms, but you could use 6. If you used all 4, you'd have interference. And you'd lose, partial on the extent, partial area on the boom, but not much. Maybe on one of them you'd lose on the corner. I'd say, what is it, 2 U's, so 20 centimeters. And the other 2 would be on the perimeter of the spacecraft, so you'd have the full 3.7 meters. So if you were to do that with 2 of them, then you would definitely increase the area and be able to lower spacecraft faster, maneuver it in shorter period of time. As far as future plans go from our standpoint, one of them, I did mention we have a mission plan next year. I can't mention the company that we're working with yet, but we're in talks with them about it, and that's for a larger spacecraft and also using 2 units to do some testing for maneuvering and potentially orbital change, trajectory change. But then drag-based attitude adjustment, that's going to be focused on with the AIAA mission to some degree, and then we'd like to see what the limits are on upcoming missions. And then again, I keep referring to this, the orbital change possibilities. That to me is a big one, because if we're able to actually change the orbit without thrusters, then we've just added a whole new level of versatility to passive maneuvering. Some references here. One of the gentlemen on the reference list sitting here, Dave Guglielmo. Nice to have you. And that's it as far as the presentation is concerned. I hope I covered some of the material. It was sort of high level, but if you have any questions, I'd be more than happy to answer them based on some of our experience. Sure.
Yeah. I'm just trying to understand your mission scenario.
Okay.
So let's say you are at the 400-kilometer altitude assumption, right? Then you drag the things that allowed you to slow down, allowed you to change the altitude, obviously. So when you bring down to 100 kilometers, do you usually pull back and let the things or increase the speed to burn out?
So no, we have not. The idea, I mean, you could do that as long as you still could communicate with the spacecraft and it's functioning properly. But at that point, the way that it's, the numbers, the way that they were determined was based on full extension, and there's no change in the area of the spacecraft once those booms are extended. So if you're just talking about a straight deorbit, once the booms are fully extended, they would remain in effect, and they would also burn in the atmosphere with the spacecraft.
So isn't it to slow down the speed when you try to enter the atmosphere?
So we're continuously trying to slow down the speed. And then if you can visually, if you can imagine that the booms are at the back of the spacecraft, so it looks like a dart, and then they have the full extension. One analogy that one of my colleagues likes to use and has used a few times is that the booms sort of act like a skydiver but in space. So if you can imagine where a skydiver has their arms and legs out, and then they can change their position by moving them. They can't increase their altitude, obviously, but they can change the drag profile so that they can control where they're entering into, or where they're moving toward. Then it's a similar type of state with the way that the D3 affects the spacecraft. So in this case, all of everything is going to be out in the position that creates the most amount of drag, and maintain that until it actually enters the lower Earth atmosphere and starts to burn up. So, yes.
I have a question. How much time does it take to deorbit? Let's say from 500 kilometers.
Oh, right. So yeah, that was on that calculator. That's probably easier just to look at it than try to explain it. So you can you can look at this here, this chart, and you can see that the this is based on a maximum of 5 years. That was our target because that's the 5-year rule by the FCC. And orbital life with D3, you can see the exact days that we were able to calculate. And we used that with the calculations, by the way, came from NASA DAS, so debris assessment software. And so are they exactly correct? Probably not, but I'm sure that they're close for the most part. Does that answer the question?
I'm just curious about why is it 5 years? And what do they determine based on the 5 years? Not 5.5, not 6 years.
That's a great question. We've been trying to figure that out ourselves. So originally there was a mandate that NASA had. It was 25 years. And so this is just coming from what I know and just conversations I've had. Then their Space Force had an interest in deorbiting these non-functional spacecraft because they were afraid it would interfere with what they're doing or planning. And so there was a big drive on their side to lower that from 25 years to 5 years. No real explanation why. And then the FCC, because they have to sign off on the commercial launch approval, they actually had it within their power to just change the number and then decide whether or not they're going to issue the launch approval for any type of commercial vehicle. So that 5-year rule does not apply to government agency vehicles, although I think they're, as far as I know, they're trying to comply to that.
We should still try to do 25 years. Yeah.
Yeah,
all the propellant, right? That's for 25 years.
Right. I don't know where that number came from specifically, and I've never been able to find out. It almost seems like it was arbitrary, but I'm not sure. Yes.
The first time I heard about the 5 years were from Europe.
From Europe, is that right? So you think it was ESA or some maybe came out of there?
Maybe it's a reference.
Yeah, and it seems like it's catching on because ESA now they're talking about a 5-year rule. So is the UK, and I believe they're already beginning to institute it. Australia, New Zealand, Taiwan, and there's probably a few others out there moving in that direction.
So the FCC can.
Yeah, I have a.
FCC cannot.
This is John Breeze. I have a question in terms of, so you're basically looking to partner with people or companies that space developers that actually actively own space objects and then helping them deorbit them safer. So are you actually going to be taking on the liability of that it's going to be actually deorbited properly, or what if there is failure on your end? Are you're basically taking on the insurance liability for the object as well?
Oh, no, we're delivering the subsystem and then they're integrating it. So, I mean, it would be similar to the satellite operator purchasing a transceiver and it doesn't work. I mean, ultimately, it's the operator spacecraft. We don't have ownership on that, but it should help them rather than hurt them in the sense that as space insurance becomes a larger issue and a larger concern, insurance companies will be more than likely interested in having some kind of a control or deorbit system on a spacecraft that in most cases wouldn't have one, because many of these satellites, the smaller ones particularly, are just they're being deployed and they have no control. And so the idea being, they're under a certain altitude, they're a certain size and mass that they're going to deorbit and burn up on their own. But if that doesn't account for maneuvering out of the way if something's coming at them, or just changing position or bringing spacecraft down to the deorbit altitude. And then another huge interest, just that we've heard from other operators that really like the concept of being able to do multiple missions with one spacecraft. So, if they don't have a thruster system on the spacecraft, but they want to be able to do 2 or 3 different missions with the same spacecraft at different altitudes, they could go to the highest altitude, go down to the next one, and then go down to the next one, and then deorbit the spacecraft. And again, in many cases, these same operators would not normally have had any kind of control at all. So this allows them a cost-effective way of doing that without installing a complex thruster system on the spacecraft. So that's another huge interest as far as this passive maneuvering is concerned. I don't know, did that answer your question?
Yeah, no, I think it did, absolutely. I see where you're coming from a business standpoint, but it seems like you would have some liability there if the insertion point was caused life and limb below to fail or other issues as well.
Yeah, so, well, again, the way we look at it is that we're eliminating risk, not adding to it, because if they didn't have the D3 on their spacecraft, it wouldn't change the mission parameters. And with the targeting element, they're also able to deorbit over, say, an unpopulated zone like the Indian Ocean or something like that. So,
Gotcha. Sounds good.
and there was another question.
Yeah, I have a question. Can you use it for remote sensing satellites? I mean, when you talk about maneuvering, lowering the orbit, like lowering the orbit, take a picture, use struts to go up. Yeah. Can you do it like that?
Sure, in theory, there should be no reason why you wouldn't be able to do that. So that would, yeah, right. You could have thruster. You could have a hybrid. It doesn't have to be just passive, but maybe something with small solid propellant thrusters on it, so you could raise the altitude back up. You know, that's definitely a possibility. Yes.
Two questions.
Sure.
The first one is FCC can only control the launch the United States, right?
FCC, yes, correct.
Is there international law saying that you have to, deorbit in 5 years?
So, no, and again, this is not my area of specialization, but from what I do know, most of the launches right now are conducted in the United States. So even if it's let's say a foreign country has a payload going up or spacecraft going up and they're launching from the US, then they still have to conform. As far as other entities are concerned, other countries are concerned, then they're in control of that if it's launching out of their jurisdiction. But I do know, just like Kwang Han mentioned, that ESA and most of the at least Western Europe right now is planning on instituting a 5-year rule. I know the UK is, and again, New Zealand and Australia are also following suit. So I imagine it'll catch on. I mean, everyone sees the value in keeping space clean, especially in the LEO environments. I don't think there'll be much pushback. Well, once it catches on.
The second question is, I heard that if you just want to use it as a drag, that's just a one-time deployment.
Mhm.
So could be simplified. Use a spring, for example, right? One-time deployment.
Rather than using motors, yeah, we talked about that before, where it would be spring loaded. The only there's benefits and drawbacks. I mean, some of the benefits are the probably will lower the mass, and then we call it a one and done. So, and then the springs would deploy it. But again, you have to have, from a reliability standpoint, I don't know which is better. I mean, do you want to have a motor controlling the booms and sending them out, or are we going to have springs that don't release and you have some kind of an actuator that doesn't work? I don't know. That's a good question. That would be a good engineering test, maybe a use case to try out.
I would say spring definitely is more reliable than the motor.
It probably would be in just a one and done scenario, right? Anything else? Dave, you look like you've got a question.
Yeah, I'm just thinking through that. In terms of the spring, I don't see any reason you couldn't do it. I'm just kind of thinking if there's space in there, no pun intended. Because last time I looked at this, there's a shell over another shell over the motor. Is it still eventually?
Yeah, basically. Mm-hmm.
So if you wanted the spring, you could maybe use a smaller inner shell if you don't have to fit a motor in there. Then you could potentially get a spring in there, but I'm just thinking that's 3 meters. About how many rotations are we making? Like 30, 50 or so? I don't remember the exact number.
Yeah, it was around 30, I believe.
Yeah, I'm just thinking if there's room to wind it up that much. In theory, you could. I mean, you could take the motors out. You have room. I'd have to see if we can get a spring that has that much travel on it.
Right, or some kind of a spring-loaded revolving mechanism, but it would also have enough force to push the booms out, because the tighter, I'm sure you know, the longer the boom and the tighter it gets, the more force you need to push it out. So.
Or you put something heavy on the end and just spin it up, just pull it out.
I'm an electrical engineer. I don't trust electronics.
Yeah, experience, right?
Yeah, this is why I don't have a smart fridge.
We went as simple as possible. This is a demo right here Kwang Han has, and we had this. This was actually at the symposium up in Silicon Valley last week, and it's also been the small sat in Utah and to Europe, and it's still running. And I was surprised it was still going. So it's still going strong. I think we're close to 10,000 cycles we figured, but it's not going extending out the full amount because for the demo the booms are a little smaller, but yeah, I mean, so far it seems to be working pretty well. Yes.
With that in mind, your demo that I've been watching for an hour plus, what scale is the demo? Is this half scale, third scale?
So no, this is exactly the size of the actual unit, except for the booms, because you couldn't have, you wouldn't be able to have the booms, right? So yeah, but everything else is identical. So except for the booms will extend out 3.7 meters, so again about a little over 12 feet.
So that's how long are the booms that are in your demo versus the real?
So yeah, so the booms that are I think they're 15 centimeters, I want to say. They're not extending all the way out. I believe we had them, our mechanical engineer locked them to make sure they weren't coming out and, whacking people walking by. So, right. And the controller mechanism too. It's not a PCB that we would normally use. It's just it's a power system we purchased from Amazon and just connected it to it. But to that point though, we did get a really nice compliment from the folks over at Axient, and they said that it integrated real easy, and they were able to basically fire it up just quickly within the same day that they did the integration and start doing functional tests. So that made us real happy because we made this version for Axient last year and integrated it in it was almost a year ago, May of last year. So. Anyone else?
Yes. Considering your tools use drag satellite, how would it integrate with or capture satellites made from materials such as wood or living cells, which may not conduct electronically or respond to electromagnetic fields in the same way as traditional satellites? Additionally, could your technology be adapted to accommodate such biodegradable or biologically based satellites degrees? I suggest also you can add to the same tools that you have some step for decomposition, so you can send it there and start the decomposition process in a space instead of taking that satellite to Earth to decomposition here and recycling it here for Earth.
Right, and I'm happy that you brought that up because it was I didn't mention the actual boom materials and the geomagnetic effects. So the booms are made with austenitic steel. So the idea behind that is that they're not going to be magnetic. They're not going to become magnetically charged through induction, which might cause the spacecraft to start spinning or to start not responding the way that we would like it to. So from that standpoint, I don't see a reason why you wouldn't be able to use it with a satellite made from various different materials. One of the other ideas that we've been experimenting with is in terms of the booms is carbon composites. So that's something that we might look into later as well. But if I understood your question correctly, in order to avoid the magnetic effects, we use the austenitic steel for that. So I'm not sure if that answers the question you had or not.
My question, I wrote again my question in chat. I meant some satellites made from live cells and or from wood, and they not reflecting with the same way as materials, as metals. So usually they end by sending some other things to start the decomposition step outside. So it's like step before they leave to end the process. So if we need to end early the process to get rid of the satellite early, before 5 years, for example, or
Oh, so you mean if you have a payload on the satellite that has biological entities on it, and then you wanted to,
no,
let's say, lower the space, you wanted to stop the mission life cycle early, then would you be able to do that? Is that because, yeah.
I meant the satellite itself made by wood or live cells, not metal. So how we drag it, and also if we need to end its life there outside, could be starting the decomposition step early by your tool, by starting the decomposition early instead of dragging it in Earth.
Yeah, you would be able to start the demise earlier if you wanted to, so that you essentially would create a burn up of the satellite, even if it was made with wood or with living material.
Living cells, yes. So I wonder whether I just suggesting that because it's not going to reflect same way like you explained in your beautiful presentation, you could use the same tool to send the what is needed to start the decomposition process early.
Right, yes, and you would be able to do that. So if that was part of your mission science or the experiment, then you could actually use the D3 to do that, to be the catalyst for that.
Okay, thank you.
You're welcome. Any other questions? Okay, looks like that was it. All right, thank you. Thanks again.
Folks, actually, if you have more questions, actually, we have a panel after Isabel's presentation. Actually, she is ready. So get your question ready. After Isabel's presentation, the three speakers work together to answer more questions. So, all right, Isabel, are you, let me stop the sharing. Let's see.
All right. Hello, everybody. I hope you can hear me well.
Yes, we can hear you, but I
Okay.
think we need to, wait a second, we need to stop our, 1 second here. We can start to present. Yeah, that's right. Here.
Okay.
I think you should be able to share your screen.
Great. So, okay, I share my screen now. Can you see it?
It's just coming up. 1 second.
Mm-hmm.
Let me see if I can.
So,
I don't know which way, but all right. I think is everybody here
yes.
okay with the? Oh, okay. So I think it's okay to go ahead. I will try to maximize the screen here. That one. Very good. And also this one. This can keep it more.
At the corner. The corner is good. Below. One more.
Electrons complicated. This one?
One more below. That one.
No, just
Oh, okay.
go back.
Okay.
I think it's okay. Just go ahead.
All right, can I start?
Yes.
Great. Yeah, thank you, everybody. And we are very sad to be not with you in the room right now. But I think we can do it online just as good. So today I want to speak with you about capacity building for a sustainable space economy. Briefly about my background, I am the founder of Space Debris DAO and the co-founder of the Institute for Legal Transformation. My name is Isabelle Miro. And with the Institute for Legal Transformation, I've been giving governmental trainings in foresighted policymaking. And that's also how I got to space law and the challenges for space debris, because we help governments prepare for a sustainable space community to develop their laws with a futuristic mindset to anticipate the future challenges that we see with like international space law, with space debris, and an emerging space economy, and to apply foresight thinking to their policymaking. In this process, I've been also involved with the European Space Agency in the development of the Zero Debris Charter. I will explain a bit more about these documents later on. But the Zero Debris Charter is also one of these industry initiatives led by ESA to have a collaboration on shaping a sustainable space economy. I'm also involved with the Space Generation Advisory Council, where I'm leading the working principles for a long-term futures in space. So it's also, developing future scenarios for the space economy. And myself, I have an academic background in psychology and sociology. So I will talk with you a lot about the human factors and the capacity building part for a sustainable space economy. So down there you can see our team at Space Debris DAO and some of our advisors. So we are very lucky to work with some very committed people on space debris solutions. So let me start first with a very brief statement about space debris, right? So by now, the threat of space debris is no longer theory anymore. We already see today that the amount of space debris is increasing. We have, like already 2 years ago, already 70% of objects in lower Earth orbit were space debris. The economic costs are anticipated to be around 191 billion US dollars. That's prediction of the OECD that was made last year. And NASA also had some quite interesting reports on the economic cost of space debris. And when we talk to businesses and satellite operators, I think to highlight these economic costs are very important, because then we do not only talk about the technical necessity to prepare and to adjust to zero debris compliance, but also to talk about the economic need to shift. And also, of course, we already see re-entries of space debris. So space debris does not stay in space. But in lower Earth orbit, we also, of course, have the re-entries that are already happening today, like small pieces of debris. So we're not talking about like massive objects, but you know, it's a matter of scale in the end. So when the amount of space debris increases in space, we also see an increase in re-entries that can eventually be harmful for life on Earth as well. So these are some aspects that show that the threat of space debris is very real, even though sometimes you know, it's hard to observe from Earth. So in this whole debate about space debris and shifting to a more sustainable space economy, we often talk about the circular space economy, right? So maybe you can hold your hand up if you know about the circular space economy, or if you're like are actively working on it. Great, because this is like a concept that is under development by many people around the world, and where we think about, okay, how can we have a sustainable space economy, of course, but what does it mean, right, to be sustainable in space? So we talk about life cycle assessments and sustainable design. So when we develop a mission, to have very early on certain design principles that we keep in mind, right? So it's also about in-orbit capabilities, so that we are developing now the technologies to be able to repair satellites, to refuel satellites, right? So that we are not dependent on like this linear launching mission and then deorbit or like burn a satellite when it's no longer serving any purpose, but to actually have a whole in space manufacturing capabilities. Another aspect of the circular space economy is regulation, of course. I will talk about this later a bit more in detail. But of course, when we are moving or like shaping the whole economy, regulation is a huge part of it. Actually, regulation is guiding this whole process oftentimes, which is why it's here at the center, and it's quite important when we talk about capacity building for such a circular or sustainable space economy. Of course, recycling is also part of it. So to figure out which materials can be actually reused, and this is like also something to be considered very early on already. And end of life management, of course. So I mean, design for the mice is currently something that many people are recommending. Also in the 0 Degree Charter, the design for the mice is something that we are highlighting there as well. But also there's many different approaches to how to actually organize or design this end-of-life management, because the mice or like burning things in the atmosphere may not be sustainable over the long term, depending on the materials and the chemical reactions that can happen in the atmosphere later on. So there's like a lot of uncertainties still in these elements, but overall, this is something that is worthwhile to look into when we're working on more sustainable solutions for space. So now in the previous presentations, we've been talking or hearing a lot about the technical solutions, also the technical challenges. And so in this presentation, I want to highlight a bit more the human side of this sustainable shift and how to build the capacity to actually implement the solutions, because like active debris removal capabilities and even standards for docking mechanisms and so on, like a lot of these technologies are already under development in many areas of the world, but still we do not always have the capacity, including the regulation and so on, to actually implement those solutions. So the developing this is like part of the shift to a more sustainable space economy. And what is capacity building? So of course we need to develop the knowledge, which means also, you know, the knowledge and the research on what we're dealing with. We need to know, okay, how many pieces of debris do we have? How can we track them? Especially the very small pieces of debris. There's huge knowledge gaps, right, on how to keep an eye on those kind of risks. Skills, and which is basically just the workforce, right? So students and even like employees, to keep them educated on material, on research, and life cycle assessment, and to keep them engaged in contributing to more sustainable space economy. Because of course, many people in the space industry already know about space debris and the issue, but still there is like a lot of new skills, a lot of new knowledge to be passed on, ideally already in universities. And this also means we need like systems and networks to address these challenges. We already see like the 0 Degree community that was initiated by ESA, that goes beyond the traditional allies, right? So it's not just ESA itself developing guidelines, but it's ESA opening an initiative that is open to space actors around the world to actively participate, because we see there also that, you know, like the local space agencies, they're very important and impactful, but we also need to have more global dialogues and more global discussions on what is developed where and which approaches which region following. Yeah, so can you still see my screen? Because for me, something is flickering. Okay. Well, so when we talk about capacity building, so how can we actually now build this capacity? And in this presentation, I talk about 3 different pillars of capacity building. One part is the mindset, is like foresight thinking. It means like, how do we think about the future of the space economy? How do we approach this problem, right? Like, what is the mindset we are applying to it? Like, are we able to anticipate long-term futures, or are we only planning for the next 5 years? So this makes a big difference in how we develop systems and regulations in the first place. Then I talk about legal transformation, which is a way of policy making, where you combine foresight thinking with policy development. So legal transformation means, okay, we envision certain scenarios, right? So there's a Kessler scenario, which may be the worst case scenario. And if that worst case scenario happens, like how can we develop regulations or policies or guidelines in order to mitigate the damages, for instance. And the third pillar is economic incentives. And those are about, okay, when we are having not just the worst case scenario defined, but also the best case scenario, how can we actually incentivize all stakeholders and all actors to contribute to this future scenario that we envision? So how can we incentivize companies to be part of and invest in the technologies that are necessary to reach a zero-degree future? So first, let's start with foresight thinking, because foresight thinking is very useful when we talk about not just the next 1 to 5 years, but actually about the long-term future. And when we are talking about a new space economy, we are entirely shaping a new era of humanity, right? So this can be like hundreds of years into the future, and it's just starting now in these recent few years. So how do we approach long-term futures? And therefore, it's very important to understand what foresight thinking is and isn't, right? So it's not predicting the future, but it is it's a process, like a strategic process that helps you to anticipate the future, to anticipate challenges, opportunities, to observe trends, and to develop those scenarios that I just mentioned, where you choose to, okay, do I want to go to the best case scenario? What milestones are necessary to get there, right? So it's like a strategic planning for long-term futures. And another way of, another mindset thing that we need to consider when we talk about shaping a sustainable space economy and long-term futures. What do we see when we see, for instance, this? So are we seeing an American man on the moon? Or are we seeing humanity in space, right? So this is something that already Neil Armstrong kind of mentioned when he set his the first foot on the moon. That's one small step for a man, but one giant leap for humankind. And right now, we are still having this competition, right, between nations to be the next one on the moon, to build a station on the moon, to stay there and to go to Mars. But after all, it's also something, when we talk about the long-term future, that cannot be done by one single actor. It cannot be done by one single company or person or nation. It requires global collaboration. And after all, we also see in the Outer Space Treaty, space is a shared frontier of humankind, right? So this this awareness is something which is very important when we start to collaborate and we start to develop future solutions. And of course, also the other way around, when we look back to Earth, like what do we see? And most of you already know the overview effect as well, right? It's what astronauts experience when they look back to Earth, and they do not they gain this new awareness of we are already all in space, right? So we are already humanity in space, even if we all are on Earth right now. And our action, what we are doing here, very much already impacts how humanity develops beyond Earth. So this kind of like mindset challenges, they help us to question the way we approach things in the past and how we want to approach them in the future, right? So we see that space debris itself, like trashing our orbits, is kind of a symptom of the Anthropocene in space, where we have used and thrown away like linear usage over circular usage, like we want the ones we aspire to in the space economy, right? So instead of getting the resources, using them, making a product out of it, using it and throwing it away, we want to have a circular economy where we actually are mindful about the materials and resources we use, because also in space, even more than on Earth, we have a certain scarcity of resources that are available to us, since currently we have to launch everything through very high energy efforts. Also, we still have a lot of these in-group bias and good versus bad narrators when we talk about space, right? So it's still very nation-driven. However, we already know that we need the global collaboration, and it's a shared effort to build our economy together. So there will be also like challenges in overcoming the past images and narratives that we had in our minds. And you may say, okay, like, why are we talking about our mindset when we talk about space? Why is that important? Well, I already said before that regulation will be a very big part of what we shape in the future of the space economy, right? So like what is incentivized, what is punished. This is kind of guiding where we go as an economy as well. And also where technology is incentivized to be developed or not. And there's always a certain, in Germany we say Zeitgeist, which means like the spirit of a time that influences our thinking and decision making. It influences our way of thinking, and the regulations that are then the output of that. So when we look at the regulations we had for space debris or for space sustainability, there's a couple of regulations already, also international level. And when we look at, for instance, just the first one, the Outer Space Treaty, maybe you remember the historical context under which this was developed, right? So back then, the Outer Space Treaty came out of the context of the Cold War, where we had like these two superpowers mainly fighting to be the first one in developing space capabilities. But that was always in the background of showing strength and not be dominated by the other actor who may harm your country. So it was very competition driven and driven by mistrust. And of course, in the current political climate, we may still see the need, or we may still see the competition that's underlying there. But also, since we now see that there's common threats like space debris, that is a challenge that does not stop between any border, we already have these shared challenges that can only be solved together. So when we talk about regulations today, it's very important to reflect on, okay, what is the current climate we are operating in, and how do we want regulations to guide us, right? So the outcome of the Outer Space Treaty was, despite it was formed in such a competition and warfare-driven time, it was such a testament to humanity, you know? So it was still like in the focus of, okay, we all are part of this endeavor, and this is humanity's legacy, right? So despite coming from this context of a war, we already have this like very shared approach in the regulation, like in the international treaty. So there you can see how the need for okay, seeing we need to work together, seeing it's a shared future of everybody, despite the context, can make a difference. And in terms of other regulation, you see, I'm not going to go through everything in detail right now, but I want to briefly talk with you about legal transformation. That is a methodology that I taught you where we apply foresight thinking and combine this with policy development. So in legal transformation, you actually define a problem, which could be space debris, right? You develop certain scenarios with a team of experts. And this is very important to have a diverse team of experts in this process. So by involving diverse ways of thinking, like you could have a scientist who is very knowledgeable on the atmospheric impact, you may have just who knows how certain companies make decisions. You have, of course, a policymaker, you have a futurist who guides people in the decision-making process. You bring a lot of more knowledge and wisdom to one table, and then you develop these kind of scenarios, which may be, of course, the worst case scenario with the Kessler syndrome, and then, of course, in your table of experts, you have the technical expert who can tell you exactly which technologies are under development to mitigate or for using active debris removal missions. You also have maybe the policy expert who can tell you exactly where there are similar regulations from other fields or areas that could be helpful for that, right? So you bring the right minds and the right mindsets together and develop these certain scenarios and then develop accordingly visions, milestones, and policies. It's a whole process, but after all, it's just a different way to approach a problem. And the benefit of using legal transformation is that you gain a lot of time. So in space, you perhaps know, like in planetary defense, for instance, like when we know that there's an asteroid coming, is it good or is it bad news? Well, like it really depends on how much time you have to prepare. So legal transformation is a way to already anticipate future challenges so that by the time the challenge comes, you're already prepared and you already have policies or you already have the capabilities and the capacity to meet that challenge, right? So the Kessler syndrome is something we already know is a risk and we already can start preparing for it. So if it happens, we can mitigate the risk quite a lot better than if we just know that there is an abstract uncertainty for it to happen, but we do not actually develop the capabilities to cope with that. Yeah, and now that we are talking about policies, like this is the Zero Debris Charter that I mentioned earlier, and that was actually developed in a with legal transformation methodology, but quite in a spirit of that, right? So you see, it was like created by over 40 space actors. We already have more than 100 like entities signing it, as well like companies, as well as nations. It's quite a high level guiding principles, so it's not very specific. It's a 2-page document basically, but it was in a session or like in a series of workshops, a series of sessions and workshops where all these experts came together and yeah, discussed the certain the contents and the guidelines that are then came together to these principles. So I think the whole process took a few years. Like the charter itself was published in 2023, and then last year we have been continuing to work together. So after developing policy recommendations on a very high level, to just, you know, it's very basic, just saying, okay, we want to engage information sharing between between us nations, right? So the people who sign the charter, they are willing to share information with each other, which is, as you can imagine, still a very big issue in this climate of mistrust globally, where we are still in these competing nations. To just agree on, okay, we're willing to share information on space debris is already a step, and it's very important to include that, for instance, right? So first, it's just about setting certain principles that will help us to build the capacity to cope with space debris. There are still some gaps. Of course, I'm not going to go too much into detail here, but definitely in terms of atmospheric impact, there are still a lot of uncertainties. As I mentioned earlier, design for demise is currently also what's kind of recommended in the charter and the technical booklet. However, that depends a lot on the materials that are used and also knowing that we do not know everything about the potential impact there. Okay, and then, as I said, the economic incentives is kind of the way, like the last pillar, the way how we actually get there then, after all, right? So the economic incentives is something where policymakers can encourage the population or the companies or the stakeholders to work all together. Because also regulation, we see in Europe, for instance, we have a lot of this problems where there's like a lot of regulations, but it's very hard for companies to comply with them. So it actually hinders innovation, it prevents startups from joining the economy. And of course, you want very inclusive regulations. You want to enable people to participate, but you want to keep them accountable, and you want them to follow certain standards. And international law still has a problem that is not really enforceable, right? Of course, states are liable for the damages caused by the companies they're launching with, but overall, like international law still has there's no space police, right? So it's very hard to regulate with like real enforceable laws in this global matters. So incentives can be already quite a good start, where like nations themselves, they can start with taxation, for instance, or giving grants for companies who are, for instance, developing ADR technologies, or insurance companies, where we've been talking with a lot, to actually give better premiums for those companies or those satellite operators who can show that they are complying with, for instance, the Zero Debris Charter, the technical booklet, that they are actively taking measures to reduce the risk. Because by giving certain economic incentives, companies can save cost in other sections, right? Because it takes an initial investment to maybe change something in their design, maybe change something in the mission, So to cope with these costs, policymaker, as well as just like companies in the industry as well, can incentivize each other also, by keeping them accountable with contract requirements as well, or certifications to actually showcase that the majority of the companies in space are committed to mitigating space debris and to be part of the solution. Yeah, so now is my last slide about a way of thinking, and I think it's very important. If you want to go fast, you should go alone, right? So if it was about the competition to the moon, if it's who can be there first, then if you want to go fast, go alone. But if you want to go far, then go together. And when we speak about a sustainable space economy, like not just something to have like one mission or to have like one satellite constellation for one certain purpose, but an ongoing economy that is growing, or even settlements beyond Earth, there we want to go very far. And when we're going to go far, we want to go together, because then we can create this whole hub and economy that also can last. All right, thank you very much. That was my presentation. If you want to connect with me, you can find me either through my name on LinkedIn, send me an email, or you can also scan the QR code if you want to get in touch with Space Debris DAO. Then we can get your information and get back to you as well. Is there any questions? I'm happy to take some minutes to get back to you as well.
Oh, thank you.
Excellent presentation. Thank you.
Yeah, thank you. Thank you. Great presentation.
I don't know if you're aware, but the American Institute of Aeronautics and Astronautics has a committee in the Integration Outreach Division on the legal aspects of aeronautics and astronautics. Would you be interested in serving on that committee?
I'm happy to learn more about it. If you could send me an email on this, that would be very appreciated. Or I can just get your name somehow.
It's in the chat.
Okay, wonderful. Thank you very much.
Okay, there's a question here by.
Can I reach it? I can go there. Isabel, thank you so much for a good presentation. I have a follow-up question here is, you indicated there is $191 billion, right, per year economic impact. I just wonder, could you tell me a little bit, how do you calculate that number?
Yeah, I got this number from a report from the OECD in 2024. I'm happy to get you the slide somehow because I got the source for it there. If you want to check the report, and there's also a report from NASA, also exactly on the economic cost of it.
Okay. So
if you're online, I can put it in the chat.
I think some of that number really is the risk, economic risk that is out there. Potentially, that's not the cost, but potentially it could be 1.9 billion or more. Literally.
Yeah, it's very hard to calculate these projections, right? So it's of course an estimation. But yeah, there's quite a few reports, particular on the economic risk, which can be very important when we not just talk to the technical people or the policymakers, but actually to the business leaders.
So the risk, meaning the satellite could be, they hit each other, right? Somehow. And that's part of on the risk, correct?
Exactly. There's there's certain extents to which you can calculate the risk, of course, because it also depends what was the purpose of the satellite, right? When we talk about a GPS network, or if it's for internet connection. So there's varieties and it's high uncertainty, so very hard to predict that. But yeah, I will check if I can put the report in the chat somehow.
Okay, thank you.
Actually, people can hear you even without microphone, but with microphone they can hear more clearly. 1 second.
Hello, Isabel. My name is Kwanish. Thank you for the speech. I have a question. It's just interesting. I saw that 12 countries already take part in your program. Could you say what countries are in?
I'm not super up to date on that. I assume it's the ESA member states. So the Zero Debris Charter was initiated in Europe, right? So many of the European member states are then part of, undersigned the charter as well. But I know that the organizing team, they're also in contact with states and companies outside of ESA itself, because it is like a global initiative. Yeah.
Okay, thank you.
Actually, I have a question.
It's not long enough.
Oh, it's not.
Yeah.
It's on now.
Yes.
Thank you. That was great. I really enjoyed the presentation. A quick question on the Kessler syndrome. Do you have any data in regard to what determines when that actually starts, if it does start? Or I've heard some people even speculate that we may even be in the beginning stages of it now. curious if you have any data on that.
I personally do not, but I've also came across different people on this who are already saying like we are already kind of started in this cascading effect. But I do not have a good source for it right now. I just know that like Leo Labs and various other tracking companies like the space situational awareness companies are having lots of data on the amount of debris that is there. But to actually give an accurate statement on when this Kessler syndrome is happening, I'm not aware currently.
Okay, thank you. And real quick while I have you here, in terms of, we were talking earlier about the 5-year rule in the United States, being that you're in Germany, I believe. Do you have any information on a similar type of regulatory system in Europe right now, or?
Yeah, so I'm in touch with people from the European Commission who are kind of like in the process of it, right? So the European space law is under development. It was already announced for last year. It was postponed 2 times. So there's currently no information on the exact time frame for deorbiting. Because in Europe, it's like, you know, we only learn publicly about the law when it's been through the committee, like through the commission. So unless the law is published, we do not know. Also, Germany itself, we do not have a space law even. So the European space law will be quite a big news for many space actors, because in Europe, of course, in Germany, we are, I guess, waiting also for the European guidelines.
Thank you very much.
Do you have online people here there? If any specific question for Isabel? If they have no specific question for Isabel, then I think it's good we start the panel. Then you can ask a question for any of the speaker or all 3 of them. But if you have any specific question for Isabel, please go ahead as well. By the way, for people here, we still have coffee in the kitchen, donut, heart-shaped Valentine's Day, you know, having fun. I'm sorry, Isabel, next time, please come here. We'll have the best donut cake for you. So, and by the way, if you, I think it's a good situation to network here, and Guanghan has a wonderful demo, and Eric is here in person. But if you are really, really hungry, there's actually a cafeteria just across the street on the west side. So if you're really, really hungry, you can just grab something quickly and back. Otherwise, we have donut here, temporary, you know, if you are really in the crunch for something. So why don't we just start the panel discussion, and we'll let Guanghan handle the panel. So Isabel, please stay online. People can ask questions for all 3 of you.
Hello, everyone. And I think this is the first try for the 3 speakers to have joint session. And we talk about this with Isabel for a little more than 1 year, right? And to get something together, and later on we discuss the space sustainability, and then we discuss with Eric on the technology development, and gradually we put together some solutions and beginning portion of the ecosystem. So this has been a gradual development, and we started our journey a while back, and I started 16 years ago, and not knowing what space industry is. And my background has been the starting in a place where there was no space industry, and being the first trying to figure out what to do. And so right now with the space sustainability, we are all in the same boat globally, and although we have started this journey for a few years, and gradually they are taking in shape. So it's good to be a part of the pioneering ecosystems and started to put together people together to work on the same problem. So this journey has been a new discovery for us, and and we're trying to make it into ecosystem and realistic business. And so we do welcome more people joining forces and putting together a series of technology development and research and demo and making it into productization and commercialization, and then system-wise helping to solve helping to solve the problem and provide solutions. So as you can see from the three speakers, and there's a lot of work to be done, and we're just scratching the skin of it. And there's a lot of regulatory support, policy support, technology development, and verification and environment that needs to be developed and to make it to be successful. And it's not easy task to do. So that's why we started to have this session, and that's why we are here today. And so as the boss, maybe I would first hand to Isabel to share some comments.
So I did not get the entire question. So it's about the regulation that are emerging.
I'm just sharing the thoughts, and
yeah.
Maybe it's your turn to share your thought.
Yeah. So I can definitely relate with like this whole sustainable space economy is something that emerged, like I feel like in a common topic like last year a lot. So I also spoke to a lot of these emerging space sector, right? But you just said like many people experience now that their country for the first time has a space program at all, right? So many people across the world are now just learning about that there is a space industry going on. And they may not even know about space debris. They may not know about the long-term consequences of what it means to be a spacefaring nations. So I think, personally, I think there's something very exciting and a great opportunity for people across the world to now be all involved in this awareness that humanity has now the capability to engage and be present in space. But I think also there is a great danger or threat that still many people are kind of left behind by not even knowing, right? Like many people do not know that there are space programs at all. So like the education part, I think is very important to get people globally on board. Also, like I think online approaches like this are amazing to be more accessible, right? I've been to many conferences in person last year, which I think is great and gives you certainly a deeper depth when you can talk face to face. So I wish I could be with you in the room right now, but also having these online formats, I think can be very good for especially the emerging space nations and the people living there to first, get a first understanding what's happening in space, and to also understand that they can be part of it, that they can, study and educate themselves in the right fields to contribute to a sustainable space economy, because also we will need the manpower, like the human power, to build everything, right? So I think having a very inclusive approach is very important now these days. Yeah.
Great. And the next question I have is for Eric. Can you share some of the experience of how you were able to, what were the background history of how you were able to evolve in such innovative solutions and become a pioneer in developing such technologies? And maybe you can share your experience.
Sure, absolutely. Well, thank you. So the way that I really began on this path dates back to about, well, I would say almost my childhood, but from a business standpoint, 2016. I mean, I've always been interested in space, and the space industry just began to flourish maybe around 2010 or so, and became a possibility for many people to become engaged in. And there was always this concern that I had, though, about the space debris issue. And I had heard about Donald Kessler and the Kessler syndrome, as Isabel pointed out. And it just seemed like it was alarming to me because and to Isabel's point and to Kwang Han's point about how people are, we sometimes take it for granted because we're in the space industry, but so many people are unaware of really what's going on, and that there's even a thriving business building right now, an industry building, and around this subject that I almost have to step back and catch myself and say, wait a minute, they may not know what it is that we're talking about here. And just on the concept of space debris alone, I remember bringing it up, and I still do sometimes, and find that people look at me sort of strange, cross-eyed, and they go, oh, that's a problem. And yes, it's a big problem, and you wouldn't believe how many of your daily activities and terrestrial activities are governed by orbiting space satellites, including everything from banking to the internet, et cetera. And all it takes is for those satellites to no longer become functional, and you're going to have terrestrial problems. So from that standpoint, that's when the gears started turning. And my business background is in financial technology, but I also have a formal education in aerospace science. And so I was thinking, well, how can you put this together and make it functional and actually create a solution? And that's sort of where the path started. And one of the most difficult parts of it for me was, at first I thought, well, it would be great if we could go ahead and just somehow come up with technology that can remediate the problem and just attach to debris or to derelict satellites and remove it. But that's much easier said than done. So the thought crossed our mind and our team that we formed, which was officially formed in June of 2020, that, well, maybe another approach is to go ahead and stop the problem before it starts. And that's what led us down the path of creating a device that could go ahead and deorbit a satellite or a spacecraft after the mission's over and not just float in space. So essentially that's how it started. But, originally also, I think everyone gets the impression that everything's focused on engineering and science in this industry. It's gone past that now. We're at a point where it's about to become a truly thriving industry, and it requires skill sets from all different backgrounds. And that's great, in my opinion. So people that are interested in this don't feel limited just because maybe your skill set's not focused on a scientific or engineering background. We need all sorts of people involved to get engaged in what we're doing. And there's going to be plenty of opportunity as time goes on.
And my next question is for all of us, and what kind of challenges do you see going forward on the topics of space sustainability? Any of the two?
Isabel?
Yeah, of course. I mean, one challenge I think we still face is the collaboration in terms of data sharing, which I briefly mentioned before, right? We still, unfortunately, are a lot in this like every nation for themselves kind of thing. But there's like very importance on like approaching this problem together. But also can just like be an exchange on like, okay, be an exchange with each other for the standards that people are developing, also for the interfaces, right? When we speak about the circular space economy, where you can actually dock on a certain satellite and drag it or something to have like a conversation on if there are standards for interfaces or not. There's a lot of like these global conversations that need to happen still, and I think to manage this is still a big challenge that needs to happen on on a global level.
Eric?
Yes, I think to just narrow the focus on a technology level, space situational awareness and actually being able to detect debris much better than we're doing now is critical to not only avoiding a collision, but also discovering different ways that we can go ahead and remove existing debris that's now a problem. And it's really interesting because at one point in time, the larger pieces of debris were considered the issue. And now I hear NASA's interested in debris that ranges from as small as 1 millimeter to 3 millimeters. Or, I'm sorry, 1 centimeter to 3 centimeters. And that's almost impossible to forecast trajectories on or to identify. So I think space situational awareness will be helpful, and that would be helpful also to all parties in the world.
The challenge that I see as an entrepreneur in this space is not only issues involved with myself and working with other players, and the issue is also we see players in our field with many new startup and founding members. Starting a new technology development is not easy, and the starting up of the technology development has all of us needs to go through the valley of death and for bringing up the innovative ideas and coordinating with the ecosystem to drive new technology. So that is from my experience, and maybe the two of you can share some of your experiences.
Sure, I know about the Valley of Death. We've been through it. It's definitely exists. Right, in terms of funding, I mean, there was a point in time where if you had a good idea and you wrote it on a napkin and showed someone that was a venture capitalist, they would probably fund it. Those days are long gone. So my understanding is that there is money coming back into the space industry and investments. However, it's much more, let's just say, vetted, and it's not as loosely distributed as it used to be, which might be a good thing because it means that people that are entering the space industry are being much more careful and selective about why they're doing it and what their technology is.
And yeah, I can also maybe add a bit on that. I mean, of course, also the location you're looking in is very different. Europe is also still like a very different location from the US when it comes to investment and entrepreneurship, of course. So of course, like the location is part of the challenge as well when you talk about the entrepreneurial challenges. I think what already works well often is the collaboration with space agencies. I mean, in Europe, we also have like the commercialization gateway from ESA, and I think, I mean, a lot is kind of supported with that, or helps also entrepreneurs to be a first collaborator with ESA and then getting funding elsewhere. And I also talked to a few investors recently over time who were actually new to space, but who learned about the space economy and are now interested in also getting involved in it. And also many traditional industries that maybe are not directly invested in space through like satellite operations or like through moon rovers or something, but they may be beneficiaries of the space industry. I think there's also a lot of potential where companies maybe indirectly benefit from the space economy, right? So the companies who actually benefit from getting the Earth observation data, right? To think of, okay, they may be actually interested in a sustainable space economy because they have like their business model based on the data they get from satellites. So I think there are a lot of these indirect connections where people also maybe are not super aware of yet. But I mean, even in terms of advertising, I think we see a lot of non-traditional companies maybe somehow getting involved with space.
And yes, and that's very good thought. And from my experience, we have to live one day with the valley of death and having to live another day for super scale up. And my question is, sometimes they happen at the same time. And how do we manage that? And I think in my experience, I'm managing both and at the same time, and just want to dig the panels brain a little bit, pick the panel's brain a little bit on how you will manage the both of the situations.
Well, I think Isabel brought up a good point about ancillary businesses that are centered around maybe a space specific type of technology or business model. And that to me is important so that you can also see that there may be other applications to what you're focused on and working on. And if you have that, it's even better because it does allow that scale up potential. And also just moving into, unless you have something that's highly specific, but has a, I mean, just from a business standpoint, a high demand, it's probably difficult to make it work over time unless you've already thought of a way that has scaled up applications. Just my thought on it.
Isabel?
Yeah, I think I wish there was like a master strategy or a solution for this. I think unfortunately, like the entrepreneurial part is always kind of the hardest you can choose, I feel like. So I think like part of the challenge is the challenge. And then I mean, so I think from my personal experience, like to really talk with many people and network many people in the industry and also outside the industry to really make sure that people know what you do and to know what your stand from, what you're willing to work for. That often you may be finding collaborations with other entrepreneurs or other teams maybe where maybe it's not your initial idea, but still maybe you find a bigger opportunity with like which is still your mission or still your vision, but maybe a different use case for your technology or something. So I think a certain openness and openness to share your ideas and to talk and openness to actually meet people and network, I think on conferences and so on, that's always been very valuable for people to expand their network and to collaborate with each other and to maybe connect when you hear somebody else talking about their idea. Maybe you can think of like someone where I have a good contact for that person. Maybe that could help them in their next step. So when everybody thinks that way, I think an economy can grow much better in general. But yeah, I think it's an ongoing challenge for everybody who chooses to be an entrepreneur.
Well, that's you two just brought up something that's deep in the heart of my experience too. And from my experience, we have already done all the capital investment, heavy capital investment a few years back, and also lived through the valley of death and survive and keep, as Isabel mentioned, keep knocking on all the doors possible, trying to gain revenue and trying to have more R&D done to bring up new technologies, trying to work with different players and to drive up the system number and system implemented on the field, and so that the new technologies are on the market being used and helping to hopefully have a system implemented, tested, and have future systems, hopefully being able to contribute in the space sustainable space environment. So that's from our point of view. And should we open for questions?
I just have one thought I'd like to add. This isn't really specific to a problem, but it's just an observation. And I've really never witnessed any type of an industry where people are willing to help each other so much. And they realize that it takes an entire group of people to solve these complex problems. And it's just exciting to see that collaboration. And I think without it, we wouldn't be able to do what we've already done, much less what's probably going to happen. So total agreement with both of you on that.
Isabel, should we open for discussion? Can
Yeah, I think it's ready.
Yeah.
Okay.
Where the panel's discussion has been is would like to share the discussion with the audience. Thank you.
It's okay. They can hear you.
Okay, so, okay. I have one comment and one question. The comments, I really admire three of you. Background's not aerospace, but you start your own business. If I were you, I probably like coming here at home to worry about it. Where's the next income? Yes, but you guys are doing so great here. That's my comment. I appreciate that. You share time with us. My question really is, do you see the Trump 2.0, in particular Southern California? I apologize, two of you may not be living in Southern California. Does that look like the Reagan's Star Wars 2.0 again? Do you see that things are going up or coming down, in particular, really in the private sector? Okay, besides Elon Musk, right? And he got the different business, and Blue Origin different business. But if you don't have $1 billion, do you see that there are opportunities more or less?
Would you want to start, Isabel?
So I'm not exactly sure if I understood the entire question. But roughly what I got was you were asking about the second time of Trump and the collaboration with Elon Musk and how that impacts the American space sector. Am I right?
Yeah.
Okay. Well, I don't know. That's a very short answer. I like from my personal intuition so far is that they are very ambitious in their goal. I think like Elon Musk is very known for his ambition to go to Mars, right? So I personally would assume that they are pushing forward with space and space economy. I'm also aware that they're not the greatest fan of the moon anymore. So there may be some conflict with the Artemis program, but I'm not up to date on how detailed, like I'm not super deep in that part.
My personal opinion is I look at it as more of a business cycle point of view. And 2022 was great for new space getting funding. And beginning of 2023, we faced the Silicon Valley Bank crisis. So, and then 2023, we also faced federal funding payment from November to April until Congress signed the payment release. And so there were a lot of the payments being delayed for 5 months. For the smaller companies, that was very difficult. And then we lived through 2024, and we have the current administration, and we're still trying to see what the effect is, so we don't know yet. But for one thing, we are sure is we will see change, and we will try to find out what the change is going to come. So that's what from what I'm seeing. I don't know what Eric is seeing.
Scrap Artemis, it's over. No. Well, one thing I do know is that I mean, there's some of my friends that work at NASA. They're fond of saying no Buck Rogers, and I mean, there's definitely truth to that. Of course, you need financing for a heavily capitalized industry like space, but then again, that's not always true. There's all sorts of different technologies and applications that can be utilized, including some that are not necessarily that have such high hurdles. I would have to say that if there's the only thing that I can think of without at this point in time, because again, none of us really know what's going to happen, is that if there's a cut in government funding particularly for new and smaller companies, I think that will be detrimental to new concepts and ideas. However, if it maintains the level that it's at now and there's more expansion and more venture capital that comes back into the space industry, then we'll probably see better years ahead of us. That's the way I would look at it. It's hard to say, but I have heard that Space Force in particular is encouraging many venture capital firms and individuals to work with the government, and they're giving them not necessarily a premium or some sort of a sponsorship for these people if they get engaged with space companies, but they're encouraging them to work with them, and they're willing to help them and it's the commercial side, the private side, with the government side, and they want that money to go out and lead to new developments in the space industry. So I don't know if that's going to change, though. I think we're sort of in the dark on that.
Okay, thank you. Looks like good news there.
I think so.
At least from business cycle, I think last year was low in business cycle. So this year, we don't feel any lower than last year. At least that's from my point of view.
I'd like to just chime in and say that 4 years is very small compared to the sustainable space economy and how big it's going to be. It's a minor glitch on the screen, really, the political mess that's going on, and it's really overtaken everybody way too much. But I do have a question that is related outside of American politics, but is related to it somewhat. Maybe Isabel can chime in on that, and that is in the U.S., we're actually not allowed to work with Chinese space companies. And I'm wondering if you, or in the space industry, the Wolf Amendment, very restrictive thing that's really hurt the American space economy. But in Germany or in ESA, you're allowed to much more, even though it might go up against NASA's some of like the Artemis Accord and things of that nature. How do you see that as really playing into the space sustainable economy and how benefit and what they're doing now, because we're in the dark on really what they're doing with this space economy?
Yeah, so I do not work directly with ESA myself, right? So I cannot say so much about ESA's policies or what they are like up to with others. I know that we collaborate a lot with Japan, for instance, with JAXA. They do a lot with the European Space Agency together. In general, I have witnessed, like in the sustainability and the space sustainability field, I've like encountered a lot of collaboration also, like cross-regional. Last month, no, in December, I've been in Hong Kong and Hong Kong University. There was a conference with more than 20 space actors coming together. And there we had like Russian, Chinese, American, European, Indian, like, you know, like the major space players coming together, not the governmental representatives, but like companies and people, you know, working together. And there's like certain regions like, you know, Hong Kong or Switzerland, like certain places that are kind of like inviting people as a neutral ground and foster those collaborations. And for me, like this conference was also quite a small conference, and people are still in touch from that, right? So oftentimes it is kind of these conferences or these like direct networking events where people then meet. And of course it's difficult for the US because when there's like restrictions in whom you're allowed to collaborate with, then of course there's like only to a certain extent where this meetings are very beneficial. But even there, you know, like even in Hong Kong, we had a woman from the American regulation background. So I think it's baby steps in that field, because nations know that they cannot do it alone and that it requires global effort, but there is like a lot of work to be done to, you know, slowly start collaborating across borders and maybe on very certain, clearly defined projects at first. So maybe it's gonna be very tiny things to collaborate on at first, and then that builds trust eventually for bigger missions.
Thank you for that.
I think I can share a little experience. I have experience in US and Asia, and being in the forefront, maybe before 2017 timeframe, there were the situation was different from current situation. Current situation is I see more bimodal. I don't know how to describe it. And there are more restrictions, and companies are more prone to be selective, one camp versus another camp. And whereas 5 years ago, 7 years ago, it was not as clear, but of course at that time the geopolitical situation was different. And so for the next few years, we will be in current situation that if you are launching with the US or if you are launching with China, so that determines which way you do business, I think.
I actually have a question for Kwang Han. In regard to, I mean, it's obvious that there's a new moon race, right? And it's also geopolitically oriented and motivated. Do you think that from your experience that that's going to have a lasting impact over, not necessarily over a current administration, but over the long term from both an economic and business standpoint, as well as maybe from an arms race standpoint, with the moon being considered a springboard for Mars, and then also the resources that are available?
I don't think I know the answer for that question. But as a company in the involved in the business, we try to work with what's workable under the circumstances.
Fair enough. Sounds good.
Yes.
I don't think nobody knows the answer, right? I said on the earlier, but personal, I feel that Star Wars 2.0 again here because of the armed races. And in particular, you talk about the Space Force, right? They are really prepared that overall the competition between United States and China, maybe even the East there as well. And for example, China is going to get the sample back from Mars before 2030. And our program right now call for sample return after 2030. But Trump said we must win the war. So I think he's going to change that. But I do not know how he's going to do it.
Just, I mean, going back to the Space Force subsidizing the private industry, and that conversation came out before we knew who was going to win the last election. But again, I haven't heard any changes in that policy, but it sounds to me like there's definitely a strategic interest in financing private companies, whether it's through venture capital or otherwise, so that there's a competitive element in that area. So yeah, again, it's definitely open game. I mean, we don't really know what's going to happen.
Yeah, I think as industry players, maybe just this 1 month, we do feel a little difference as maybe resource allocation and attraction of resources. That is maybe the difference between last year and this year. I don't know whether that is answering the question.
Just a comment that came to mind. I have noticed lately that, and I'm sure that Artemis and the moon race, and I mean, we have Intuitive Machines is ready to launch a spacecraft to the moon, and also Firefly mission is already launched. That there seems to be a shift in interest in the moon now, more than I remember ever seeing in the last maybe 8 to 10 years. So even the technology, whereas before there was a lot of interest in low Earth orbit and also geo, I would say a little bit, I'm seeing more interest in very low Earth orbit, and I'm seeing a lot of interest in the moon. That's where I would say there's a big shift in the last maybe year or two. On the commercial side.
I think on the accessibility side, for the commercial, for the lunar missions, that's also more accessible.
I would just like to comment on going to Mars. I have a slogan that says, Mars is a dead planet. Venus is alive and kicking. And that's the planet that is really going to be really beneficial to human space development. It's going to have a lot more to offer than Mars will in the near term and in the long term, I think. There's a lot of great things. And it is also been on the radar in the last year. Finally, people are starting to realize, let's start organizing some missions to Venus, because it really is a super dynamic planet that we need to get to and really understand. Thank you.
John, you're right. John, you're right. If you pay attention, actually, AIAA Los Angeles section has a couple of Venus exploration events in the past few years. Just most recently, we have a scientist from European Space Agency on Venus. It is indeed a very interesting topic, and JAXA also sent spacecraft over there, and Magellan. We also have the PI or the messenger. Professor Solomon also talk about and we also have the JPL speaker, Patricia. She was talking about this decadal study. Patricia, Yeah, so we do elevate to pay attention to Venus, and of course Mars is very important. What I want to say is that you mentioned about this situation of small business. We actually fully understood the situation. The Elevate Los Angeles section has been having events, with the small business, and there were some suggestions. Maybe small business can team up with the prime industry. As you know, the Northrop Grumman here, they got a lot of money, and you still have Boeing. Of course, they're in some kind of situation, but we do hear, actually, Dave also pretty aware. Actually, almost every month we have new, business come in or expanding their business. In case you heard of it, there's a Gitai, Japanese American company, the space robotic company. They work with JPL. We actually have them here doing the same role, but they're literally just next door, and they just bought a big facility, expand, and actual scale lab. They also bought 35 square feet facility in Torrance. I still have to find out where they are. Then we have K2 Space, we have Microcosm, then we have there's a Plasma something here, and then we have Millennium Space System. I don't know, Millennium is a small business or not, but it should be, right? And honestly speaking, I just met their founder, Mr. Stan Durban, 2 days ago. We are inviting him for our February 21st. But what I'm trying to say is that the Los Angeles section, at least for us, what we can do is try to include the business into our AIAA family. So we highly embrace the small business because it's no longer three giants plus NASA. So we have a lot of scattered. Actually, people didn't realize there's the DZ Aerospace. They make fasteners for space, So they're actually hit in impulse space. In case you heard Redondo Beach, they were doing this orbital transfer. Tom Mueller, former space people. So there are a lot of opportunities. So we've been trying to connect people, put it here into the business. Of course, nationally, Mr. Kevin Burns also mentioned we have the IOD outreach. We have policy group, and honestly speaking, actually, I try to invite Guang Han for this sustainable space sustainability task force led by Moriba Jia. But of course, you understand you're busy. And by the way, we also have I'm with the microgravity space process technical committee. So we love to embrace small business, so we can enjoy, share the resources and talk to each other. So maybe some prime business got interest in your technology or supply, and they were willing to incorporate you into their system. Actually, we have a company, they were from Bay Area. They try to make some kind of space tubes, and I think they talked to Northrop Grumman. I don't know what's going on afterwards. But there was some kind of successful story with networking with AIAA. So highly encourage you people to, you don't necessarily have to join AIAA membership, but participate in our activity. Thank you so much for today. And another thing I also was trying to share with people was that, of course, Elon Musk is not considered as a small business, but he did start from our LA section, how AIAA can help the small business. But I think the key is participation. And also, other than that, we also have the education resources. In case you didn't know that our USC student branch, the Rocket Propulsion Laboratory, they just broke the world record altitude of amateur rocket. It's not just student rocket, it's amateur rocket altitude record, passing common line, 134 kilometer. It's amazing. Then we have the Cal State Long Beach student branch. They just got selected by NASA for one of the 10 universities in the States for right share. So I'm just trying to mention that there are a lot of opportunities. And in case you know, we have Aerospace Corporation, just mentioned Space Force. It's literally right here. We regularly have events with them, and they come to our event. So there are many good things. I really encourage small business to participate. You might find something you other people won't know, and it might be some people you don't see regularly. For example, February 21st this year, our AIAA CEO, Mr. Clay Maury, is actually going to be here in Longdale Library. We have a student mini conference. Welcome to join us. You can meet our new CEO, and there were other company as well. And on May 14, because the president of Aerospace Corporation, Steve Izakowicz, the Honorable Mr. Steve Izakowicz, and also other people, they are going to be our awards dinner, and including Dr. James Worth. And it's a good opportunity to meet. And if your company have some technology that the AIAA section can give you awards, or we can recommend you for national award. Actually, that's what we're talking about with Kevin. So I'm just kind of coming in. We are really trying to help the small business, and also on the other way, if you have be able to participate. For example, I don't want to name the company. We have outreach to that company, have a tour, and we invited some high school students to join us. And one of them, but I think she graduated. She got the she become an undergrad, but she got a job internship in the company. And otherwise, she would have never known, about this company. And I think it's mutually. You help each other. There were resources from universities, that you might be able to tap into, and you might be able to tap into the for the prime industries. So I really recommend that. That's just some comment. And one thing earlier, there was attending online, Dina, he was talking about making satellite with wood or something like that. I think Japan just launched a wood satellite, right? I think that's why she's asking that question. So there are a lot of great things happening. I do see great potential. And the one thing you're talking about China, Russia, but isn't that the United States has the most significant spending on space, more than all the other countries combined together. So 65%. So it's yeah. So I still think there's a great opportunity for the United States business here. It's just how to distribute, how to properly allocate resources to people like you. And you also mentioned about this Utah, the Small Satellite Conference.
Yes.
So I've been telling people, AIAA is really a wonderful. Actually, AIAA used to be behind the Utah Small Sat mini conference. I've been there conference, and talking about the Silicon Valley. I respect Silicon Valley people; is highly successful. But at the same time, when I went to the Utah Small Sat conference, when AIAA was still behind it, I saw a lot of Silicon Valley people there. But honestly speaking, AIAA has been consistently doing small sat for 40, 30 long years. People didn't even notice it. So I'm just trying to say there's still a lot of things inside AIAA that you can tap into, that actually could turn into, burst into great businesses. And we have many people that, of course, you work in the Axiom space. Our new CEO actually came from that space, and so this is good to connect networking and a good family. Actually, by participating today, your name has been known for at least more than 9,000 people. They may not show up, and actually some people supposed to show up in person, they become online. So I think I encourage you continue for engaging with AIAA. I'm not trying to advertise. You don't have to join the membership, but it's good to participate.
I'm a member, by the way.
Thank you. Congratulations.
No, you're doing a great job. Thanks for all your conferences. Really, really well done. Appreciate the history too, and mentioning the power of Gwen Shotwell, who is the powerhouse behind SpaceX. Thank you.
Well, I just tell you, good. Hello. Actually, Gwen is our beloved member. Actually, she was advanced to associate member, associate fellow, honorary fellow within a very short period of time. So she's amazing, and she's been supporting us. I highly appreciate. But there are other good names, and I'm just picking this just as an example. And in case you don't, we actually I met her in Loyola Marymount University in the area of outreach. She used to be the director of the Space Command, Space Force, or SMC, before I think the second woman four-star general, Ellen Polikowski, General Ellen Polikowski. She was running Space Command here So we have a lot of good people here, but you need to find the time to meet with each other. Of course, these are the leaders. You have actually many mid management and also a grassroots engineer. So it's a really good family. So I really encourage, and of course, a lot of people from JPL as well. That's a great family. So thank you, John.
It's worth to mention that her husband worked for JPL. So it's a small world.
Yeah,
It's all within the family.
Maybe Oh, you want to say more?
I think I'm okay.
Oh, you okay?
Mm.
Any more questions?
Any more questions?
Just an observation. Just a reminder that as we're trying to read the political tea leaves, remember that President Trump is the one who started Space Force and has promised a Space National Guard. We'll see if he follows through on the second one, but I'm hopeful that he's going to be a supporter of space since he was in his last term.
Well, he has no choice right now.
With Musk there.
Thanks for a great event. Appreciate it.
You have more?
I'm okay.
You okay? All right. Well, I think because all the panelists has fully expressed their views, this which we would love to do to have our experts and the industry leader to fully express their views and exchange the opinions and gain input from experts and practitioners in the industry. Actually, there are actually more people. Unfortunately, they cannot be here. Actually, I mentioned to Guang Han, we actually had several students doing excellent job in space debris. For example, just 2 days ago, I was doing a science field judge in a nearby Palos Verdes high school, and the girl, she did a wonderful job. She actually did a software app that you can input your parameter and give you a suggestion how a company can find the parameter like amount of fuels, orbit, to set up your mission. And last year in the ISAF, International Space Engineering Fair, I was also a judge, and there was a girl student also from Canada or somewhere. She already owned her company for retrieving space debris, and it's just the other people. So I think there's something here. People are interested. And for AIAA, each year in June, we have a planetary defense mini conference. Isabel talked about it before. We have Dr. Nahum Melamed and several people from USC. We have a speaker from JPL, other places. NASA talking about planetary defense, but that's actually include some of the space debris. Then of course, and the next month, March 15, we'll have a team up with the AIAA Microgravity Space Technical Committee, and we will have speaker from Bada Space and also from NASA. And our committee member includes some professor from several universities. So hopefully you can join us again. If no more question, you are welcome to continue to stay online, folks, too. We'll officially end the meeting now. Oh, yeah, Eric, great question.
One comment. This is for AIAA. And being that we have a JPL man here, I just wanted to mention that I went on a tour of JPL through AIAA last October, and I'd never been there before, and it was fantastic. So I just wanted to thank the organization for that.
Thank you. Yeah, and actually that's the point. That's how AIAA can help, because we are connecting to the industries. Actually some of the last year we have the student branch mini conference in spring launch. So a student really love this, and if your business established here, and you can have this talent for Rising Star, the students. We have Cal State Long Beach, UCLA, UNLV, USC, and plus we have actually quite a lot of experienced professionals. Actually, we have a visitor last year from Strata Launch, and he was talking about the working environment there. I was telling them, and also the comment from the Gitai robotics company was that one of the reasons people have business in LA, yes, it's a little bit more expensive, but you will find a lot of talented people. They might have either retire or they left earlier. In fact, actually, our former section chair, I don't want to mention the name, but he was a former director of Boeing, and I just mentioned I met the founder of Millennium Space System 2 days ago. There are a lot of talented people here. So it's a great environment, and it's like a big family, you know, like JPL people, and the JPL workers also team up with Aerospace Corporation, you know. So there are a lot of things that you need to participate and get to know. And you mentioned about this AIAA. I'm so happy you are a member. And you mentioned people like the landing on the moon. Actually, I talked to there were 3 companies that got the contract from NASA. You have Astrobotics, Intuitive Machine, and another company. Actually, there should be 4, but at least the 3 companies that had event with us, 2 of their CEO or president, they were our members, and actually they were our members since they were students. So I can really tell you that, and that they were really very excited because the AIAA, you know, got exposure for student activity to National Technical Committee, and they get to know a lot of industry people and potential resources. I've been telling people that there are things we don't know. For example, you're thinking about those vast space, Axiom, but how about Lockheed Martin? Actually, last year in Ascend, they have a very big booth on microgravity. So certainly they put a lot of quite some of the resources on LEO, microgravity. Of course, you know, they have Gateway, but they don't tell people exactly what they do. You know, you have to kind of participate to know what's going on. And I can just tell you, some of our members, they actually with Skunk Works or, you know, some other facility, but you understand in the industry, sometimes they don't talk out loud, but if you network, you'll be able to connect to the right people. So you are the third, leaders in the company, commercial company that is AIAA member, as I heard, for the small business. Yeah. So that's wonderful. Yes. Thank you. Thank you, everyone. Oh,
I want to thank Isabel for staying so late from Germany and for speaking.
Yeah.
And I also want to thank Eric for joining me in this session.
Thank you.
Yeah. Actually, Isabel, we're in Ascend. We met in Ascend last year. So you can see how this AIAA things really work out very well. Yeah. Thank you. Appreciate it. So please enjoy more donut coffee here and continue to visit the demo here. For online folks, I will put the camera close to the demo so you can continue to see it as long as Guanghan allowed us to view it. So thank you very much again. So have a wonderful day. So see you next time. Thank you.